Picture the animal you think you know, a scruffy, opportunistic, dog-like creature slipping through alleys, raiding trash, always small, always a little pitiful in the American imagination. Now picture that same animal weighing perhaps 35 pounds, standing over a white-tailed deer 4 times its size, the deer already down in the snow. That is not exaggeration. It is documented behavior across dozens of wildlife studies, from the Adirondacks to the Rockies. The coyote does not overpower a deer through brute strength, because it has none to spare against an animal built that much larger. Instead, it wins through patience, positioning, and a willingness to work as a team rather than alone. Deer are fast in a straight line, but a straight line is exactly what a coordinated pair of coyotes refuses to offer. One animal pressures from behind while the other waits along the flank, and within minutes the deer is boxed into a decision it cannot win. Wildlife biologists, tracking radio-collared coyotes in the Northeast, have recorded this pattern often enough that it is no longer treated as rare opportunism, but as a genuine, repeatable hunting strategy, most common in deep winter when snow slows a deer's stride and favors the coyote's lighter frame. The animal raiding your garbage can on a Tuesday night and the animal capable of dropping a mature deer in January are unsettlingly the very same creature. That range from scavenger to serious predator is where this story has to begin. The strategy has a name among researchers who study it closely: the drive and ambush. It works almost exactly the way it sounds. One coyote, often the more experienced of a mated pair, approaches a deer directly moving with just enough noise and presence to unsettle it without triggering full flight. The deer, sensing pressure, begins to move away from the threat it can see. That is precisely the mistake the second coyote is counting on. Positioned downwind and out of sight, often behind cover the first animal has already scouted, the partner waits in near total stillness until the deer is driven close enough to intercept. The kill, when it comes, is fast and coordinated rather than a prolonged chase. Camera trap footage from wildlife corridors in Pennsylvania and New York has captured this sequence enough times that field biologists now describe it with confidence rather than speculation. What makes it remarkable is not just the tactic itself, but the trust it requires. The driving coyote has to commit to a direction without knowing exactly where its partner is waiting. And the ambushing coyote has to hold position through the tension of an approaching deer without breaking early. That kind of coordination, built on repeated hunts together, rather than instinct alone, points toward a working partnership more sophisticated than the word scavenger ever suggested. It is the first hint this early in the story that there is far more calculation behind those yellow eyes than most people driving past a coyote on the shoulder of a country road ever stop to consider. Run your hand along the jaw of an average family dog, and you are feeling a tool built mostly for carrying, chewing, and the occasional tug-of-war over a rope toy. A coyote's jaw is a different piece of equipment entirely. Measured bite force in coyotes lands close to 300 pounds per square inch, a figure that outperforms many dogs of comparable or even greater body weight. For comparison, a fully grown German Shepherd, an animal bred over generations, partly for jaw strength, generates somewhere in the same range or slightly below it, despite often weighing considerably more than a coyote. Pound for pound, the coyote's bite is simply harder working. That force comes from a skull shaped by necessity rather than aesthetics: a narrow snout, dense jaw musculature anchored to a pronounced ridge of bone across the top of the skull, and molars positioned to crack bone rather than merely shear meat. In practical terms, that bite is what allows a coyote to finish what its pack hunting strategy starts, delivering a fast, decisive throat or nape bite capable of ending a struggle with a much larger animal in seconds, rather than 2 minutes. It is also less dramatically why a coyote can crack open a marrow bone that would leave a house cat's jaw aching just from the attempt. The strength was never optional. In a body this size, going after prey this large, there was no room for a jaw that only looked the part. There is a persistent image of predators as creatures of the single decisive strike, a flash of speed, and it is over. Coyotes rarely work that way, and understanding why says something about the kind of hunter this animal actually is. Built lean with long legs, suited more for covering ground than for explosive acceleration, a coyote is not the fastest predator in the field. What it has instead is stamina, and it uses that stamina as a weapon in its own right. A hunting group will take turns pressuring a fleeing animal, one coyote falling back to rest, while another takes up the chase, cycling through the pursuit so that the prey never gets the relief a single tiring predator would eventually offer. Over open ground, a coyote can sustain a lope for miles without the labored breathing that would force a lone hunter to break off. Against a deer, already slowed by deep snow or difficult terrain, that endurance becomes decisive, wearing the animal down through accumulated exhaustion rather than any single burst of violence. It is the same principle that let human endurance hunters on the plains centuries ago. run certain game animals into the ground long before firearms made the chase unnecessary. The coyote arrived at that same solution on its own through a body built for the long grind rather than the short sprint, and a willingness among packmates to share the labor of the pursuit rather than compete over it. Somewhere in the ledgers of federal wildlife agencies sits one of the largest sustained predator control efforts ever carried out on this continent, and its primary target for over a century has been the coyote. Beginning in the early 1900s, ranchers pushed for organized extermination campaigns to protect sheep and cattle, and the federal government answered with an agency whose entire early mission was killing predators at scale. The tally since then runs into the millions of coyotes through poison traps, bounty payments, and organized hunts, a campaign larger and more sustained than the efforts once aimed at wolves or grizzly bears. If you laid every coyote taken under that program nose to tail, the line would stretch across state lines many times over a number too large to hold as anything but an abstraction, until you consider what it represents: generation after generation of the same species targeted continuously without pause, for longer than most Americans alive today have been on this Earth, and yet the population curve tells a story the campaign never intended. Coyote numbers did not collapse under that pressure the way wolf and grizzly populations did in the same era. They held, adapted, and eventually grew. The scale of the effort against this one species is worth sitting with for a moment, not as a footnote but as the opening chapter of a much stranger story about what happens when an animal simply refuses to lose ground. For much of the mid-20th century, the primary weapon in the war against coyotes was not a rifle, but a chemical distributed across western rangeland on a scale that is difficult to fully picture. Compound 1080 sodium fluoroacetate was loaded into bait stations and dropped across grazing land by the thousands, designed to kill any coyote that took the poisoned meat. The trouble was that coyotes were never the only animals willing to eat it. Eagles, foxes, family dogs, and other wildlife took the same bait, and the poison itself had no way of distinguishing an intended target from an animal that simply happened across it first. Reports from the period describe entire local populations of golden eagles thinning out in regions where the bait program ran hardest. Collateral losses that had nothing to do with protecting livestock and everything to do with a chemical that could not tell one species from another. Public pressure and mounting evidence of that damage eventually led to restrictions on the compound's use, tightening it into a far more controlled tool than it had been in its heaviest years. The episode remains one of the starker examples in American wildlife management of a control effort that reached well past its intended target, and it set the tone for decades of debate that followed about how far a campaign against one species is allowed to go before the damage spreads to everything living around it. This is not a relic of some earlier, harsher era of wildlife management. Aerial gunning small, fixed-wing planes and helicopters flying low over open range, while a shooter takes coyotes from the air, remains a legal and actively used control method in parts of the American West today, most often contracted through state and federal wildlife damage programs on behalf of ranchers protecting livestock. The tactic exists because coyotes are difficult to approach on foot across the kind of open, exposed terrain where sheep and cattle graze and a low-flying aircraft can cover in an afternoon what a ground crew might spend days chasing across. Programs using this method report thousands of coyotes taken in a single season across some western states, a figure that surprises people who assume this kind of large-scale predator control belongs to an earlier century rather than the present one. The practice remains controversial, drawing criticism from conservation groups who argue it is costly, imprecise, and ultimately ineffective at reducing livestock losses in the long run, while defenders within agricultural communities maintain it is a necessary tool against real and ongoing predation. Both sides can point to decades of data supporting their position, because the coyote population targeted by this method has across that same span of decades continued to hold steady or grow. Whatever else aerial gunning has accomplished, ending the coyote's presence on the American landscape has clearly not been one of them. Here is the part of the story that should, by every reasonable expectation, have gone the other way. Bounty programs paying hunters and trappers for coyote pelts or proof of a kill ran in state after state for generations, stacking on top of poison campaigns, aerial hunts, and federal control efforts into a pressure campaign with almost no modern parallel among American wildlife. A species under that kind of sustained assault should shrink, retreat, and in the worst case disappear entirely the way the wolf and the grizzly did across most of their former range under comparable pressure. The coyote did the opposite. Where it once held a range largely confined to the open plains, deserts, and prairies of the American West, it now occupies nearly the entire continent, including regions it had never inhabited before the 20th century began. Wildlife agencies did not simply fail to eliminate the coyote. Judged purely by the map, the campaign against it appears to have coincided with one of the most successful range expansions of any mammal on this continent in the last 100 years. Researchers studying the pattern point to something almost paradoxical at work, a species that responds to heavy population pressure, not by declining, but by reproducing faster and dispersing farther, as though the pressure itself were feeding the expansion rather than stopping it. That paradox sits at the center of everything still to come in this story, and it is worth holding onto before the picture gets even stranger. Take a moment to consider the geography of that claim. 49 states coast to coast, desert to swamp to forest to skyline, and in every one of them, coyotes have established breeding populations. That includes places wildlife managers once considered impossible territory for the species: the Everglades, the suburbs of Boston, the concrete corridors of Los Angeles. Only Hawaii, protected by open ocean, the coyote has no way to cross on its own, remains outside that reach. This is a species that started the 20th century confined largely to the plains and deserts west of the Mississippi, and ended it having colonized nearly the entire lower 48, a spread that outpaces the range expansion of almost any other mammal in modern American history. Wildlife biologists, tracking the advance, describe it less as a slow drift, and more as a series of deliberate pushes: young coyotes dispersing from their birth territory, and simply continuing to travel until they found ground nobody else was using, sometimes hundreds of miles from where they started. Along the way, the coyote adapted to environments. Nothing in its evolutionary history had prepared it for humid southern swampland, dense northeastern forest, and eventually the asphalt and shadow of American cities themselves. The animal did not wait for permission or find some clever loophole in human control efforts. It simply kept walking, generation after generation, until the map itself had no more room left to give. If you picture a coyote, you probably picture open-range tumbleweed, maybe a sunset behind a mesa. Now picture Chicago, one of the largest cities in the country, home to an estimated several thousand resident coyotes living within its city limits at any given time, according to long-running tracking studies out of Ohio State University's Urban Coyote Research Project. These are not occasional wanderers passing through the outskirts. They are established breeding territorial animals living in cemeteries, golf courses, forest preserves, and the narrow green corridors that thread between neighborhoods, often within sight of downtown skyscrapers. Researchers who have radio-collared hundreds of these animals over more than 2 decades have documented individual coyotes holding stable territories inside the city for years at a stretch, raising litters, defending boundaries, and largely avoiding human contact so effectively that most Chicago residents living within a few blocks of a resident coyote family will never once lay eyes on it. The animal has learned to read the city the way it once read open prairie, treating traffic patterns, footpaths, and human schedules as just another set of terrain features to navigate around. It is a strange thing to sit with a predator capable of taking down a full-grown deer thriving in the shadow of the Sears Tower, and doing it quietly enough that an entire population goes largely unnoticed by the millions of people sharing the same square miles of ground. There is a particular unease that comes with realizing an animal has been in your yard without you knowing it, and coyotes specialize in exactly that kind of quiet passage. Built low, lean, and naturally cautious around anything that smells or sounds like a human presence, a coyote moving through a suburban neighborhood at dusk or before dawn will typically stick to the edges. The shadow along a fence line, the gap between a shed and a hedge, the drainage ditch nobody bothers to mow. Wildlife cameras set up in backyards across suburban Denver, Portland, and countless towns in between have captured coyotes crossing lawns just minutes after a family let the dog out or a teenager pulled out of the driveway for a late shift. Footage the homeowners themselves never suspected existed until they checked it. The animal is not being clever in some calculated cinematic sense. It is simply doing what it has always done, moving efficiently and staying unseen, the same instinct that once kept it alive on open prairie, now repurposed for a landscape of chain-link fences and sprinkler systems. That gap between how confidently we believe we know what is happening in our own backyard after dark and how little we actually see is, more than anything else, what unsettles people the first time they watch that kind of footage. The coyote was there. You simply were not looking in the right direction at the right time. Here is where the story earns a little humor. Because if you have ever come downstairs to find your garbage cans tipped over and their contents dragged across the lawn like the aftermath of a very committed yard sale, you may already have some first-hand experience with this particular fact. Coyotes are opportunistic feeders in the truest sense, and a suburban trash can left out overnight represents, from their point of view, a reliable and remarkably low-effort meal compared to chasing down a rabbit through brush. The same goes for pet food bowls left outside for a dog or cat. An open invitation that plenty of homeowners never think twice about until the bowl turns up empty and licked clean by something considerably less domesticated than the pet it was meant for. Wildlife officials in coyote-heavy suburbs routinely list securing garbage and bringing pet food indoors as the single most effective step homeowners can take to reduce coyote activity near the house, above and beyond fencing or noise deterrence. It is not glamorous advice, and it will never make for a dramatic nature documentary moment, but it gets at something true about this animal that all the talk of pack hunting deer can obscure. Most of the time, the coyote is not stalking anything. It is simply looking for the easiest calories available on a given night, and an unsecured trash can, infuriatingly, tends to qualify. This is one of the harder truths in the coyote's story, and it deserves to be said plainly rather than softened. Small pets, particularly cats and small dogs, left outside unsupervised during the low-light hours around dawn and dusk, when coyotes are most active, do face a genuine and well-documented risk in areas with an established coyote population. Wildlife agencies in coyote-heavy regions, from suburban Southern California to the outer boroughs of New York, maintain records of pet losses attributed to coyotes each year, and the pattern in those records is consistent incidents, cluster overwhelmingly around those twilight hours, and overwhelmingly involve animals that were outside without direct supervision. This is not a reason for panic, and it does not mean a coyote is lurking behind every fence. But it is a reason for the kind of ordinary precaution that generations of Americans once took for granted before coyotes became a familiar suburban presence, bringing a cat in for the night, walking a small dog on a leash rather than letting it out alone at last light, keeping an eye on the yard during those particular hours rather than assuming the porch light and a wooden fence amount to real protection. The coyote is not hunting your pet out of malice. It is doing what any opportunistic predator does when an easy, unguarded meal presents itself, and the responsibility for closing that gap sits fairly or not on the human side of the fence. Given everything already laid out, the deer hunts the bite force, the animal slipping unseen through backyards, it would be easy to assume coyotes represent a serious direct threat to people. The actual record does not support that assumption, and it is worth stating clearly rather than letting the drama of the preceding facts do the talking. Documented coyote attacks on humans do occur, but they remain statistically rare across the entire continent, numbering in the dozens per year across the whole of North America, rather than the scale that headline coverage sometimes implies, and the overwhelming majority of those incidents involve minor injury rather than serious harm. Fatal attacks are exceptionally uncommon, with only a small handful of confirmed human deaths attributed to wild coyotes recorded in the historical record, most involving unusual circumstances such as habituated animals that had lost their natural wariness of people through repeated feeding. For context, a person in coyote territory faces measurably higher everyday risk from a domestic dog from a car accident on the drive home, or from a bee sting, than from a wild coyote encounter. None of this erases the real caution warranted around pets and small children, particularly during denning season when coyotes grow more protective and more visible. But the coyote's reputation as a threat to human life itself is built on a level of danger the actual data simply does not bear out. And that distinction matters if the rest of this story is going to be told honestly. There is one clear exception to that general rule of caution over drama, and it appears each spring when coyote pups are small and vulnerable inside the den. A female coyote with pups nearby, particularly in the weeks just after birth when the young are blind and entirely dependent, can shift from the species' usual wariness around people into sudden, direct aggression if she perceives a threat to that den. Wildlife officials in suburban and park settings report a small but consistent uptick in bold coyote behavior, each spring tied directly to this pattern. Animals that would normally flee at the sight of a person, instead holding ground, vocalizing, or in rare cases making a brief charging bluff towards someone who has unknowingly wandered close to a den site. This is not random unpredictability. It is a mother committing everything she has to protecting offspring that cannot yet defend themselves, the same fierce, single-minded instinct that shows up across nearly every mammal species that raises helpless young, only harder to predict, in an animal most people assume is permanently cautious around humans. Parks departments in coyote territory typically respond to these seasonal reports not by removing the animal but by temporarily closing trails near a known den site, a quiet acknowledgement that this particular behavior is not aggression in the ordinary sense but the oldest instinct in the animal kingdom, expressed by a species we too often forget, is underneath everything else, simply a mother raising young the only way she knows how. Trail cameras mounted along suburban fence lines in coyote territory have captured something that looks uncomfortably like reconnaissance. Rather than testing a fence once and moving on footage from wildlife researchers in California and the Pacific Northwest, shows individual coyotes returning to the same stretch of fencing across multiple nights, working methodically along the base. nosing at gaps, testing loose boards, and in several documented cases, eventually finding and exploiting a weak point that had gone unnoticed by the homeowner for months. This is not the behavior of an animal blundering into a yard by accident. It looks to the researchers reviewing the footage like an animal building a working knowledge of a specific boundary over time. The same patience it applies to studying a deer trail or a rodent burrow now turned toward a 6-foot cedar fence and a gate latch that does not quite catch. Homeowners who install new fencing after a coyote problem often report a strange pattern in the weeks that follow, a period of apparent testing along the new barrier, before the animal either finds a way through or, more often, gives up and moves its attention elsewhere. It is a small, almost domestic kind of unease, watching that footage and realizing the same intelligence that lets a coyote coordinate a deer hunt with a hidden partner is on a quieter night being spent evaluating the quality of your fence installation. Behind the debate over aerial gunning and poison bait sits a plain economic reality that ranchers have lived with for generations. Coyotes do kill livestock, primarily young or vulnerable animals such as newborn lambs and calves, and the cumulative cost of that predation runs into tens of millions of dollars annually across the American ranching industry. According to figures compiled by the United States Department of Agriculture, sheep operations bear a disproportionate share of that burden since lambs are especially vulnerable in the first weeks after birth, small enough and slow enough that a single coyote, without even the pack coordination used against deer, can take one down with minimal risk to itself. For a rancher operating on thin margins, the loss of even a handful of animals in a season is not an abstract wildlife statistic but a direct hit to household income, which explains why predator control remains such a deeply entrenched practice across the ranching communities of the American West, rather than a policy imposed from outside. At the same time, agricultural researchers have found that non-lethal measures, guard animals such as llamas and specialized dogs, better fencing, and changes to calving and lambing schedules can reduce losses substantially without relying on the kind of large-scale lethal control that has failed for a century to bring the coyote population down. The economics of this conflict are real on both sides, and neither the rancher's losses nor the coyote's resilience is going away on its own. If the trash can incident earned a laugh, this one earns a grimace from anyone who has kept backyard chickens. A coyote family working a poultry setup with an unsecured or poorly latched coop can clear it out in a single night, sometimes killing far more birds than it can carry off or eat in one sitting, a behavior known as surplus killing that tends to horrify small flock owners far more than it would a rancher accustomed to losses on a larger scale. The reason has less to do with cruelty than with opportunity. In the wild, a coyote encountering a burrow full of rabbits or ground-nesting birds would face natural limits. The animals scatter, some escape, the encounter ends. A henhouse offers none of those limits. The birds are confined, unable to flee beyond the coop's own fencing, and a coyote that finds its way inside is essentially presented with more vulnerable prey than instinct knows how to ignore. Extension offices in rural and semi-rural counties across the country field a steady stream of calls each spring from newly initiated backyard chicken keepers who assumed a simple wire coop and a latch would be sufficient only to find the coop breached and the flock gone by morning. It is one of the more painful lessons in coexisting with this animal, and one that generations of American farmers, keeping chickens long before suburban hobbyists took it up, learned the hard way as a matter of course. This is the fact that finally explains why an entire century of lethal control never managed to shrink the coyote population, and it is worth sitting with because it runs against almost everything intuition tells us about hunting pressure and prey response. Wildlife biologists studying heavily controlled coyote populations discovered something counterintuitive. Removing a significant portion of coyotes from an area does not simply leave fewer coyotes behind. It triggers a biological response in the animals that remain. With competition for territory and food suddenly reduced, surviving females tend to produce larger litters, and a greater proportion of young females breed in their first year, rather than waiting. A pattern researchers call compensatory reproduction. In practical terms, a population reduced by half through hunting or poisoning in one season can, under the right conditions, rebound close to its previous numbers within a year or two, driven by the very same removal effort that was meant to suppress it. This mechanism, more than any single act of cleverness or evasion, explains the paradox at the heart of this story: why bounty programs, aerial gunning, and poison campaigns sustained across generations never produced the population collapse that similar pressure inflicted on wolves and grizzlies. The coyote's real defense was never hiding or outsmarting the hunter in any given encounter. It was a reproductive strategy that turns population pressure itself into fuel for recovery. That brings this opening chapter to its resting point, and it deserves to be stated as plainly as the evidence allows. Across more than a century of sustained, well-funded, and often brutal efforts spanning poison campaigns, bounty programs, trapping, and aerial gunning, no sustained coyote control program in American history has succeeded in producing a lasting, large-scale reduction in the species' overall population. Local and temporary reductions, yes, certain valleys or counties cleared for a season, but the broader story, tracked across decades of wildlife data, shows a population that has held steady or grown throughout the entire period it was being hunted hardest, expanding into territory it had never before occupied while the campaign against it was still very much underway. It is worth asking what that means set against everything else in this opening chapter: the deer hunts, the aerial guns, the poison bait, the vanished chickens, the studied fence lines. This is an animal that has drawn some of the most sustained lethal pressure any wild species has faced on this continent, and has responded not by retreating, but by spreading further than it had ever gone before. Whatever else the coyote turns out to be, over the course of this story, it is already clear that this is not a fragile animal clinging to survival at the margins. It is a survivor in the fullest sense of the word, and understanding how it does. That means looking past the fear and into the strange, finely tuned body that makes it possible. Step away from the danger for a moment and listen instead, because the coyote's voice is where the strangeness of this animal really begins to show itself. A lone coyote, or a small family group of 3 or 4, can produce a chorus of yips, barks, and howls that sounds to a human ear standing in the dark, like a much larger gathering than is actually present. This is not an accident of acoustics. Researchers who study canid vocalization believe the effect serves a real purpose, projecting a false sense of numbers to warn off rival coyote groups or larger predators from contested territory without the risk of an actual confrontation. Each individual coyote in a calling group tends to vary its pitch and rhythm rather than howling in unison, and that variation is precisely what creates the illusion of a crowd. A person camping in coyote country who wakes to what sounds like a dozen animals surrounding the tent has more often than not been fooled by a family of 3, doing an excellent job of sounding much larger than they are. It is a clever piece of natural theater, achieved with nothing more than a handful of throats and a bit of vocal variety, and it sets the tone for a stage of the coyote's story, built entirely around the ways its body and senses work, just differently enough from what we expect, to leave us second-guessing what we thought we knew. Wildlife researchers have gone so far as to test this illusion directly recording small known groups of coyotes and playing the audio back to listeners asked to estimate how many animals they heard. The results were consistent, and striking listeners routinely guessed numbers far higher than the actual group size, often estimating a chorus from 2 or 3 coyotes as the sound of 15 or 20 animals calling at once. The mechanism behind the trick lies in how varied and layered a small group's vocalizations actually are. Where a pack of wolves tends to howl in a way that stays relatively close in pitch, coyotes deliberately scatter their calls across a wide range of tones. Yips overlapping with barks, overlapping with rising and falling howls, each animal shifting pitch mid-call rather than holding a steady note. The human ear, built to estimate group size based on the number of distinct voices it can pick out, gets overwhelmed by that variation and defaults to assuming more individual animals than are actually present. It is a reminder worth carrying into every fact still to come in this story, that plenty of what feels like overwhelming evidence of the coyote's scale and reach, whether it is the sound coming from the tree line at night or the sense that the species is simply everywhere, now deserves a second look before taking it entirely at face value. Sometimes the coyote really is that widespread. Sometimes it is just very good at sounding that way. There is a name for this phenomenon in the scientific literature, and it comes appropriately enough from an old story rather than a lab. Biologists refer to it as the Beau-Guest effect, borrowed from a 1920s adventure novel in which a besieged fort's defenders prop up the bodies of the dead along the walls to fool attackers into believing the garrison is far larger and better manned than it really is. The naturalist who first applied the term to animal calls recognized the same basic trick at work in the natural world. A small group projecting the acoustic signature of a much larger one to deter rivals without ever needing to test that claim in an actual confrontation. Coyotes are one of the clearest examples of the effect ever documented, but they are not the only animal that uses something like it. Certain songbirds vary their calls in similar ways to make a single territory holder sound like several, and some primates are believed to do something comparable with alarm calls. What sets the coyote apart is how well its particular vocal range is suited to the trick, capable of producing a genuinely wide spread of pitch and rhythm from a very small number of individual throats. It is a small, almost literary detail sitting inside a much larger biological story. An animal essentially staging its own fortress illusion every night, using nothing but sound to make a family of three seem like a small army camped somewhere out past the tree line. The vocal repertoire goes well beyond the group howl, and researchers who have spent years cataloging coyote sounds now recognize somewhere in the range of a dozen distinct call types, each tied to a specific situation rather than randomly deployed. A short, high-pitched yip exchanged between two coyotes reuniting after time apart functions essentially as a greeting, an acknowledgement closer in spirit to a familiar wave than a warning. A sharper repeated bark, often directed at an intruder or a perceived threat near a den, serves as an alarm call meant to alert other family members and warn the intruder off at the same time. A long rising howl carries much farther and functions as contact communication, a way for a family group to locate scattered members across territory too large to cover by scent alone or to announce a boundary to a neighboring group without any need for a direct encounter. Researchers have even identified a distinct rallying call used specifically before a group hunt, a shorter sequence that seems to coordinate movement among family members preparing to move together. What emerges from this catalog is not a single all-purpose howl, but something closer to a working vocabulary, each sound carrying enough consistent meaning that trained researchers can often identify just from the recording roughly. What situation prompted a given call without ever having seen the animals themselves? For an animal this size, that is a remarkably sophisticated way of staying connected across a landscape too large for constant contact. Watch a coyote hunting mice in an open field during winter, and you will see a behavior that looks almost comic from a distance. An animal standing perfectly still, head cocked, before suddenly launching itself, nose first, into a median's snowbank. That maneuver, sometimes called mousing, depends entirely on a sense of smell, sensitive enough to locate a small rodent moving through tunnels several inches beneath snow or soil, with no visual or auditory cue involved at all. A coyote's nose contains hundreds of millions of scent receptors, a figure that dwarfs the human equivalent by a wide margin. And the portion of a coyote's brain devoted to processing that information is proportionally far larger than the corresponding region in the human brain. The practical result is a predator that can walk across what looks to a person like an entirely blank field of snow and detect with real precision exactly where a vole is moving beneath the surface, timing that dramatic pounce to land within inches of an animal it has never actually seen. It is worth pausing on how strange this actually is. An entire hunting strategy built around information. A human being has no way of perceiving at all, invisible and odorless to us, as clear as a marked trail to the animal reading it. The next time a coyote appears to be leaping at nothing in an empty field, it is worth remembering that nothing to that particular nose is very rarely the case. Pair that extraordinary nose with a set of ears built almost as an afterthought of specialization, and the picture of a coyote's sensory world starts to come into full focus. Coyote hearing is tuned with particular sensitivity to the higher frequency rustling sounds produced by small rodents moving through grass or leaf litter. And field studies tracking successful hunts have found coyotes locating and pouncing on prey from distances of many yards away, well beyond what the animal could see or smell in dense ground cover. The ears themselves, large relative to the size of the head and highly mobile, can be aimed independently of one another and of the direction the coyote's body is actually facing, allowing the animal to triangulate a sound's exact origin with a precision that would require a person to physically turn their entire head multiple times to approximate. Combined with the scent-based detection used against burrowed prey, this gives the coyote something close to a layered sensory net sound, catching what smell might miss in windy conditions. Smell catching what sound might miss beneath snow or soil. It is a reminder that the animal padding along a suburban greenbelt at dusk is operating with an entirely different map of its surroundings than the person walking a dog along the same path reading a landscape of sound and scent that runs invisibly underneath the one the rest of us are used to relying on. Anyone who has driven a rural road at night and caught a pair of glowing eyes at the edge of the headlight beam has seen this particular piece of coyote anatomy in action, whether they knew it or not. Coyote eyes, like those of many nocturnal and crepuscular mammals, contain a structure called the tapetum lucidum, a reflective layer positioned directly behind the retina that bounces available light back through the eye a second time, effectively giving the photoreceptors two chances to capture whatever light is present. In near total darkness, this doubles the animal's ability to gather usable light, dramatically improving night vision at the cost of some visual sharpness compared to daylight conditions. It is also exactly what produces that distinctive green-gold glow when headlights catch a coyote's eyes at nightlight, reflecting straight back out of that layer toward the source rather than any quality of the eye itself, producing light. Humans lacking this structure entirely see almost nothing under the same conditions where a coyote can navigate with reasonable confidence. judge distance to prey, and avoid obstacles along a route it may have walked dozens of times before. That gap in nighttime vision is part of why coyotes have shifted so heavily toward nocturnal activity in areas with heavy human presence. An animal essentially choosing to operate during the hours when its own eyes hold a real physical advantage over ours. Set a coyote's skeleton next to a domestic dog's of similar size, and the differences in the legs alone tell you almost everything about what each animal was built to do. A coyote's limbs are proportionally longer and leaner, with a lighter overall bone structure than most dog breeds carry. An anatomy shaped by generations of covering open ground efficiently, rather than sprinting in short bursts or wrestling prey at close range. That build translates directly into stamina. A coyote can maintain a steady lope somewhere in the range of 25 to 30 miles per hour for extended distances without the labored breathing or rapid fatigue that would force a heavier-bodied animal to slow or stop. Field researchers tracking radio-collared coyotes have recorded individual animals covering 10 miles or more in a single night of travel, moving between denning sites, hunting grounds, and territorial boundaries with what looks on a GPS map afterward, like an almost casual disregard for distance. This is the same physical foundation that supports the pack hunting endurance strategy against deer described earlier, but it also explains something less dramatic and arguably more important to the coyote's overall survival: the sheer capacity to disperse. A young coyote leaving its birth territory in search of new ground is not limited to nearby options the way a heavier, less efficient traveler might be. Those long legs are in a very real sense the engine behind the species' continental expansion. If the fence testing footage from earlier felt unsettling, this fact explains exactly why a fence alone was never going to be much of a deterrent. A healthy adult coyote can clear a chain-link fence, standing 5 feet tall or more from a standing start, a jump height that would require a genuinely athletic effort from most people, and comes for the coyote almost effortlessly, aided by that same lean muscle structure built for distance rather than bulk. Wildlife officials advising homeowners in coyote-prone areas routinely recommend fencing well beyond that height, often suggesting 6 feet as a bare minimum, with an additional outward-angled extension at the top specifically, designed to prevent a coyote from using the momentum of a jump to scramble over. Even that combination is not foolproof. A determined coyote, particularly one that has already identified an easy food source on the other side, will sometimes attempt to dig beneath a fence rather than clear it. Another reason, wildlife agencies recommend burying fencing material a foot or more into the ground along the base. It is worth setting this fact next to the earlier one about a coyote studying a fence line for weaknesses over several nights, because together they describe an animal that treats a suburban boundary less as an obstacle and more as a puzzle, with a solution patient enough to look for the gap, and physically capable, if no gap presents itself, of simply going over the top. Here is where the coyote's body starts telling a genuinely surprising story, one written not in behavior but in its own genetic code. As gray wolves were hunted to near extinction across the eastern half of the continent through the 18 and 1900s, the small remaining wolf populations in parts of the Great Lakes region and southern Canada found themselves with dwindling numbers of potential mates of their own species. Coyotes expanding into that same territory as wolves disappeared filled the gap in an unexpected way. And interbreeding between the two species left a lasting genetic signature that persists in eastern coyote populations today. Genetic studies conducted over the past 2 decades have confirmed that coyotes across the northeastern United States and eastern Canada carry measurable percentages of wolf ancestry. In some populations, reaching estimates in the range of 10 to 25% of their total genetic makeup, a legacy of interbreeding that likely occurred generations ago as the two species ranges overlapped during a period of significant ecological upheaval. This is not a minor genetic footnote. It represents a documented case of one species absorbing genetic material from another, as that second species collapsed toward extinction around it. A process playing out not in some ancient evolutionary past, but within a timeframe recent, enough to be reconstructed through modern genetic sequencing. The animal loping across a backyard in Vermont today may be carrying quite literally a piece of the wolf that used to live there. Genetics do not stay abstract for long in a living animal, and the wolf ancestry carried by eastern coyotes shows up plainly on a scale. A western coyote, the classic plains and desert animal most Americans picture when they hear the word, typically weighs somewhere between 20 and 35 pounds. An eastern coyote carrying a meaningful percentage of wolf DNA regularly weighs 45 to 55 pounds, and some individual animals documented in the Northeast have pushed past 60, a size difference substantial enough that early wildlife officials encountering these larger eastern animals sometimes assumed they were looking at wolf-dog hybrids of a different origin entirely before genetic testing clarified what was actually happening. The size increase is not simply a matter of eastern coyotes eating better or living in a more forgiving climate. Researchers tracking the correlation between wolf ancestry percentage and body size across multiple eastern populations have found a fairly direct relationship. Animals with a higher proportion of wolf DNA trending measurably larger than those with less, a pattern strong enough to function almost as a genetic signature written into the animal's frame. It means the coyote loping across a field in Maine or upstate New York is not simply the same animal found in Arizona, scaled up by better nutrition. It is, in a real and measurable sense, a somewhat different animal carrying inherited size that traces directly back to a species that no longer exists in anything like its original numbers across that same landscape. Push that size difference to its extreme, and you arrive at the animal. Researchers and the public alike have taken to calling the coy wolf, a term that captures, even if imprecisely, just how substantial this hybrid influence can become in certain individuals. At the upper end of documented weights, an eastern coyote with significant wolf ancestry can weigh in the neighborhood of 50 to 55 pounds, roughly half, again, the mass of a lean western coyote, holding steady around 35. Picture the difference, the way you might size up two dogs at the park. A mid-sized collie standing next to what looks like a young German shepherd. Both clearly the same general kind of animal, but carrying a genuinely different presence and physical capability. That added size is not cosmetic. Researchers studying the ecological role of eastern coyote populations have suggested that this larger, wolf-influenced build may allow eastern coyotes to hunt deer more effectively and more independently than their smaller western relatives typically manage, potentially filling part of the ecological role wolves themselves once played across that same landscape before their populations collapsed. It is worth being precise here rather than sensational. The coy wolf is not a new species, and it is not, in the scientific sense, anything other than a coyote carrying a documented and measurable degree of wolf ancestry. But the term persists in popular use for good reason, because the difference in size and capability between a lean western animal and its heavier eastern cousin is substantial enough to notice at a glance. The wolf ancestry carried by eastern coyotes did not simply add general size. Genetic research comparing skull structure across coyote populations with differing levels of wolf ancestry has found specific associations between that ancestry and jaw and skull characteristics suited to handling larger prey, a broader, more robust jaw structure, and increased bite strength beyond what body size alone would predict. This matters because it changes what an animal is actually capable of hunting, not just how large it appears standing in a field. A western coyote taking down a deer, as described earlier in this story, typically relies heavily on pack coordination and endurance to compensate for a body not naturally proportioned for prey that size. An eastern coyote carrying stronger wolf-derived jaw structure and greater overall mass is working with a body better suited to that same task from the outset, requiring less of the drawn-out coordination and endurance strategy that a purely western coyote population depends on. Researchers studying deer predation patterns across the Northeast have found eastern coyotes taking adult deer with somewhat greater frequency and independence than western coyote populations typically manage, a pattern consistent with this inherited physical advantage. It is a striking example of how genetic material from a species in decline did not simply vanish when that species collapsed. It moved sideways into a closely related animal, and in doing so handed that animal tools it had not previously possessed on anything like the same scale. The genetic picture in eastern coyote populations turns out to be even more layered than the wolf connection alone suggests. Alongside measurable wolf DNA, genetic surveys of eastern coyote populations have also detected smaller, more limited traces of domestic dog ancestry in some individual animals. Evidence of occasional interbreeding between coyotes and dogs that has occurred sporadically as the species expanded into landscapes dense with human settlement and inevitably unsupervised or free-ranging dogs. This dog ancestry tends to appear at much lower percentages than the wolf contribution and is far less consistently present across the broader eastern coyote population, showing up as an occasional genetic thread rather than the widespread signature that wolf ancestry represents. Researchers studying the phenomenon note that coyote-dog hybrids, sometimes informally called coy dogs, tend to face certain disadvantages relative to purebred coyotes in the wild, including breeding cycles less well synchronized with the seasonal timing that gives coyote pups the best chance of survival. A mismatch that appears to limit how far dog ancestry spreads through a wild population over successive generations, even where it does occur. Taken together with the wolf ancestry documented in the same populations, It paints a picture of the modern eastern coyote as something genuinely unusual among North American mammals, an animal whose genome carries a written record of every major canid it has crossed paths with over the past century. Wolf dog, coyote alike, blended together by circumstance rather than by any deliberate breeding program. Move past the genetics for a moment and back to the living animal, because even a coyote's tail is doing more work than it appears to at a glance. Near the base of the tail, coyotes carry a supracaudal gland, sometimes called a violet gland, for the faint scent it produces. A patch of specialized skin that secretes chemical signals used for both territorial marking and communication between individual coyotes. When a coyote drags or brushes its tail against grass brush or a scent post along a territorial boundary, it is depositing information there in a form other coyotes can read, long after the animal itself has moved on. Details about identity, reproductive status, and how recently the marking occurred, functioning something like a message left in a mailbox for the next coyote to pass through the area. The tail itself, thick and bushy compared to a domestic dog's, also plays a visible signaling role independent of scent, held in different positions to communicate mood and social standing during direct encounters between coyotes. Tucked low in submission, raised in confidence or challenge. It is a reminder that a great deal of coyote communication happens on a timescale and through a channel entirely invisible to a passing human observer. Chemical messages left on a fence post at 3 in the morning read and understood by the next coyote through that same territory the following night. An entire layer of conversation running quietly beneath the more obvious howls and yips already described. For anyone trying to tell a coyote apart from a wolf or a large dog at a distance without the benefit of a genetic test or a close inspection of the jaw, the tail carriage offers one of the more reliable visual clues available. A coyote moving at its typical trot holds its tail low, often angled slightly downward and tucked closer to the body than either a wolf or most domestic dog breeds tend to carry theirs during normal movement. A wolf, by contrast, typically holds its tail out straighter and somewhat higher, a difference wildlife trackers and field biologists use as one of several quick visual indicators when trying to identify an animal glimpsed briefly at range. This low tail carriage is not simply a passive physical trait. It functions as part of the animal's broader signaling system, and coyotes will adjust that carriage noticeably depending on context, lowering it further during moments of caution or submission, and raising it somewhat during confident, assertive movement through familiar territory. Wildlife photographers and researchers working in areas where coyote, wolf, and large dog populations overlap have come to rely on this detail as one of the fastest, lowest-effort ways to make an initial identification before closer examination becomes possible alongside build, ear shape, and the narrower muzzle already described. It is a small detail, but one worth carrying forward the next time a low, quick shape crosses a field at dusk, and the question of exactly what you just saw comes up. At a distance in poor light, a coyote's silhouette can genuinely confuse an untrained eye, and the resemblance it most often gets mistaken for is not a wolf or a large dog, but a fox, an animal from an entirely different genus. The confusion makes some visual sense. Coyotes carry proportionally large, pointed upright ears and a notably narrow, tapered snout, features that echo a fox's general profile far more closely than they echo the broader head and rounder muzzle typical of a wolf or most domestic dog breeds. Combine that with a coyote's relatively slight overall build compared to a wolf, and a quick glimpse crossing a road at dusk or moving along a distant tree line can leave even an experienced outdoorsman second-guessing which animal they actually saw. The similarity ends quickly on closer inspection. Coyotes stand considerably taller and heavier than any fox species native to North America, and their legs-tail proportion and overall gait diverge from a fox's the moment there is time for a longer look. But that first impression, the sharp ears and narrow face reading as something almost fox-like before the rest of the picture resolves, is common enough that wildlife officials fielding public reports of animal sightings in coyote territory regularly have to sort through calls describing what turns out to be a coyote being reported with complete sincerity as an unusually large and bold fox. For anyone who spends time reading tracks rather than sightings, the coyote leaves behind a signature nearly as distinctive as its silhouette. A coyote's paw print tends to run narrower and more elongated, more of a true oval than the print left by a domestic dog of comparable size whose tracks typically read rounder and more compact by comparison. The claw marks in a coyote print also tend to sit closer together and align more directly with the pads themselves, a subtler detail, but one experienced trackers use alongside the overall shape to make a confident identification. Wildlife trackers add one more test when conditions allow it. A coyote's front two toes typically sit closer together and slightly forward relative to the rest of the print, a proportion connected to the same lean, efficient leg structure that supports its long-distance stamina built for a straight ground-covering stride rather than the somewhat looser, more varied gait many dog breeds display. In snow or soft mud, an experienced eye can often follow a coyote's trail for a considerable distance, purely from that print shape and the spacing between steps. A straight businesslike line, rather than the wandering investigative pattern, a domestic dog typically leaves while exploring the same terrain. It is one more small piece of evidence alongside the ears, the tail, and the narrow snout that this is an animal built with almost nothing wasted, every physical detail bent toward efficient, purposeful movement across open ground. There is one more piece of equipment worth examining before this stage closes, and it goes back to those large mobile ears already mentioned in passing. A coyote's ears are not fixed in a single forward-facing position the way a human's effectively are. Each ear can rotate independently of the other, controlled by a set of muscles at the base, capable of swiveling the ear toward a sound source without requiring the animal to turn its head or break its attention from whatever it happens to be watching at the same moment. In practical terms, this means a coyote can track two separate sounds simultaneously. One ear angled toward a rustle in the grass to one side, while the other stays oriented toward a family member's distant call from the opposite direction, processing both streams of information at once rather than having to choose between them the way a fixed ear listener would. Researchers studying predator sensory systems consider this kind of independent ear mobility a significant advantage for an animal that needs to monitor a wide territory for both prey and potential threats simultaneously effectively, doubling its capacity for directional awareness without any need to move the rest of the body at all. It is a small mechanical detail, easy to overlook, next to something as dramatic as a coordinated deer hunt, but it belongs on the same list as the nose and the eyes. One more piece of an animal built quite literally from the ears down to miss as little as possible of what is happening around it. Anyone who has spotted the same coyote in a neighborhood across different seasons may have noticed something that looks at first like two different animals. A coyote's coat changes dramatically with the season growing in a dense, insulating undercoat beneath the visible guard hairs as winter approaches. A layer thick enough to significantly bulk out the animal's silhouette and trap body heat effectively enough to let it remain active through genuinely harsh winter conditions rather than retreating into extended dormancy the way some other mammals do. Come late spring, that same coat sheds heavily over a period of several weeks, leaving behind a noticeably leaner, almost ragged-looking animal that can appear thinner, mangier, and generally less healthy than the same coyote looked just months earlier, buried in its winter coat. A transformation dramatic enough that wildlife officials regularly field concerned calls each spring from residents convinced they have spotted a sick or starving coyote in their neighborhood, when in most cases the animal is simply mid-molt and in entirely normal condition for the season. That seasonal coat is doing real functional work rather than serving any decorative purpose. Insulation calibrated tightly enough to the local climate that coyote populations in different regions of the country show measurable differences in coat density suited to their particular winters. It closes out this look at the coyote's body on a fitting note, an animal that even in something as simple as its own fur is quietly, constantly adjusting itself to whatever the season happens to demand. Step now from the body into the mind, because what researchers have documented about coyote behavior in cities over the past 2 decades amounts to one of the more striking examples of rapid behavioral adaptation recorded in any North American mammal. In rural and wild settings, coyotes are naturally crepuscular, most active around dawn and dusk, with meaningful activity during full daylight as well. Long-term tracking studies from the Urban Coyote Research Project in Chicago and similar programs in other major cities have found that coyotes living within dense urban environments shift that pattern almost entirely toward the night, with the overwhelming majority of movement and activity concentrated in the hours after most human activity has quieted down and before it resumes with the morning commute. This is not simply coyotes being naturally more nocturnal than their rural counterparts. Researchers comparing individual animals tracked as they moved between rural and urban portions of the same general territory have observed the shift happen in real time, the same animal becoming measurably more nocturnal as it settled into a more human-dense area. It represents a genuine behavioral adjustment made within a single animal's lifetime, rather than something bred into the population over generations. Evidence that the coyote is not simply tolerating city life at the margins, but actively recalibrating its daily rhythm around ours, trading the daylight hours it might prefer in open country for the relative safety of darkness in a landscape it now shares with several million people. If the nocturnal shift suggests a general caution around humans, this next piece of behavior suggests something considerably more specific and frankly harder to explain away as simple instinct. Researchers running camera studies at urban road crossings frequented by coyotes in cities including Chicago and Denver have documented individual animals repeatedly pausing at the edge of a road, appearing to track the flow of traffic and then crossing during identifiable gaps rather than darting out at random moments regardless of oncoming vehicles. Some of the tracked animals were recorded successfully navigating multi-lane roads with heavy near-constant traffic over dozens of separate crossings across a period of months. A survival rate that struck the researchers reviewing the footage as difficult to attribute purely to chance timing. Whether this represents genuine learned traffic assessment or a more general caution and pause then move pattern that happens to align well with traffic gaps remains a point. Researchers continue to study carefully, wary of overstating what the footage actually proves. But the behavior itself, coyotes consistently avoiding vehicle strikes at crossings they use repeatedly over long stretches of time, is well documented enough now that wildlife biologists studying urban predator adaptation treat it as one of the clearer examples of an animal adjusting its behavior specifically around a hazard that did not exist anywhere in its evolutionary history until roughly a century ago, and doing so with a degree of apparent success that continues to surprise the people studying it most closely. Zoom out from any single road crossing, and a broader pattern starts to emerge from the GPS data researchers have collected on urban coyote movement. A pattern that looks less like an animal wandering opportunistically through a city and more like an animal navigating a deliberately chosen route. Network. Tracked coyotes in cities across the country show a strong, consistent preference for moving through storm drainage systems, culverts running beneath major roads, and the overgrown corridors that follow rail lines and highway easements, infrastructure built by humans for entirely different purposes, that the coyote has repurposed into something functioning, almost like a private transit system running underneath and alongside the city's own streets. These corridors offer real practical advantages from a coyote's perspective: cover from human view, relative quiet, and connections between fragmented patches of green space that would otherwise require crossing open, exposed, and dangerous stretches of road and sidewalk. Researchers mapping these movement patterns across multiple cities have found individual coyotes using remarkably consistent routes night after night, following the same culvert and rail corridor sequence to move between a denning site and a favored hunting area, a level of route fidelity that suggests genuine spatial learning and memory of the urban landscape rather than random wandering. It is worth sitting with the image. This creates an entire hidden layer of coyote movement, running beneath the ordinary experience of city life, using the very infrastructure built to drain stormwater and carry freight as its own quiet highway system. Among the more specific findings to come out of urban coyote research is the discovery of just how much these animals rely on a particular category of urban land that most residents never think of as wildlife habitat at all. Studies tracking radio-collared coyotes across Los Angeles have found individual animals establishing stable, long-term home ranges centered on golf courses and cemeteries. Two types of land use that share a set of characteristics. Coyotes evidently find highly favorable, extensive, open green space, relatively low nighttime human activity, reliable water from irrigation systems, and enough tree and shrub cover along the edges to provide safe daytime resting sites. A golf course in particular offers something close to an ideal urban coyote habitat, almost by accident of its design: expansive mowed turf that supports healthy rodent populations for hunting water hazards and irrigation ponds, providing a steady water source and stretches of rough and tree line, offering exactly the kind of edge cover a coyote favors for moving unseen. Cemetery grounds offer a similar combination on a smaller scale: quiet, minimally disturbed green space that goes largely untouched by the kind of foot traffic found in a public park. Researchers have documented coyote families raising multiple litters of pups successfully within these settings over consecutive years, treating a stretch of manicured fairway or a quiet section of headstones with essentially the same functional value a patch of undisturbed prairie would have offered the same species a century earlier. Move now from where coyotes live to how they actually organize their lives together, because the picture that emerges is considerably more structured than the word wild predator typically suggests. Coyotes are generally monogamous, and a mated pair once formed will often remain together across multiple breeding seasons rather than the shifting, opportunistic pairings sometimes assumed of wild canids. Long-term field studies tracking known individual coyotes have documented mated pairs staying together for several consecutive years, cooperating not just during the breeding season itself, but year-round, sharing territory, coordinating hunts, and jointly defending that territory against intruding coyotes from outside the family group. This bond appears to extend beyond simple reproductive convenience. Researchers observing established pairs have noted behaviors suggesting a genuine working partnership, coordinated territorial patrols, shared responsibility for provisioning pups, and in several documented cases, evidence of one member of a pair appearing to grieve or show behavioral disruption following the death of its mate, spending noticeably more time near shared den sites and showing reduced hunting efficiency in the weeks that followed. None of this should be read as claiming coyotes experience loss the way humans do a claim well beyond what the evidence can actually support. But the underlying social structure, a stable cooperative, long-term partnership between two animals raising young together across multiple years stands in sharp contrast to the solitary, opportunistic image the word coyote still carries. For a lot of people who have never looked closely at how the species actually lives, the coyote family structure extends further than the mated pair alone, and this next detail is where the species starts to look genuinely unusual among North American predators. In a meaningful number of documented coyote family groups, yearling offspring from a previous litter delay dispersing from their birth territory and instead remain with their parents through the following breeding season, actively helping to raise the new litter of pups rather than striking out immediately on their own. These helper offspring, most often but not exclusively female, have been observed bringing food back to the den, helping guard pups while the breeding pair hunts, and in some cases participating directly in group hunts alongside the adults, functioning as genuine working members of an extended family unit rather than simply tolerated stragglers. Researchers studying this behavior, known more broadly across the animal kingdom as cooperative breeding, have found that litters raised with the benefit of helper siblings tend to show measurably higher pup survival rates than litters raised by a breeding pair working alone, a real, quantifiable advantage that likely explains why the behavior persists. It is a pattern more commonly associated with certain bird species and a handful of highly social mammals, and finding it well documented in an animal still widely regarded as a solitary opportunist says something important about how far the coyote's actual social life diverges from its popular reputation. An extended family working together across generations, rather than a lone predator making its way through the world entirely on its own. There is a question buried inside the previous fact that biologists have spent real effort trying to answer, and it gets at something genuinely puzzling about how evolution is supposed to work. A yearling coyote that stays behind to help raise its parents' next litter is in the most basic evolutionary sense, delaying its own chance to reproduce. Spending a year of its life gathering food and standing guard for pups that are its siblings rather than its own offspring. On the surface, that looks like a losing strategy effort spent without the direct genetic payoff that reproduction itself would provide. Researchers studying cooperative breeding across multiple species, coyotes included, would have found the explanation in a concept called kin selection. The idea that helping close relatives survive and reproduce still passes along a meaningful share of shared genetic material, since a full sibling carries roughly half the same genes a helper would pass on through its own offspring. Combined with practical factors, limited available territory for a young coyote to claim on its own, and better survival odds gained by remaining within an established defended home range, the decision to stay and help starts to look considerably less puzzling and more like a reasonably calculated bet. It is a subtle piece of evolutionary logic playing out inside an animal most people still picture as a lone, opportunistic scavenger. One more example of behavior in this species, running quietly deeper than its reputation ever gave it credit for. Return now to the hunt itself, because the coordination described earlier between a driving coyote and an ambushing partner raises an obvious question. How exactly do two animals without spoken language manage to time and position a hunt this precisely? Researchers who have spent extended periods observing coyote hunting behavior in the field have found the answer largely in body posture and movement cues, rather than any vocal signal, a coyote shifting its ear position, altering the angle of its head, or changing its pace and direction in ways that appear to communicate intent to a nearby partner without a sound being made at all. A slight lowering of the head and a shift toward a stalking gait signals a partner to hold position, while a change in direction toward a specific patch of cover can prompt the second animal to begin quietly repositioning toward an anticipated escape route before the prey has even reacted to the first coyote's approach. This kind of silent, posture-based coordination makes sense given the nature of the hunt itself, where any vocalization would risk alerting prey that has not yet noticed the threat, but it requires a level of shared understanding between hunting partners that takes real time and repeated cooperation to develop. Mated pairs and established family groups that have hunted together across multiple seasons show noticeably smoother, more efficient coordination than newly formed pairs, attempting the same maneuver evidence that this silent language like Any other improves with practice and familiarity between the existent, specific individuals involved. Building directly on that silent coordination, researchers have documented a specific and recurring hunting pattern that goes beyond the general drive and ambush strategy. Already described one that shows real anticipation of how prey is likely to behave rather than simple reactive pursuit. In this pattern, one coyote deliberately approaches a resting or feeding animal rabbit ground squirrel, or occasionally a fawn, in a way clearly intended to flush it into motion rather than to catch it directly, while a hunting partner has already positioned itself along a route the prey is likely to take based on the terrain and the direction of the approach. This requires the ambushing coyote to essentially predict prey behavior in advance, reading the landscape, the wind direction, and the likely panic response of a specific prey species well enough to choose a waiting position before the chase has even begun. Field biologists studying this behavior in open grassland habitat have noted that success rates improve considerably when the same hunting pair repeats this strategy across multiple attempts, suggesting the animals are refining their read of a given piece of terrain over time, rather than starting from scratch with each new hunt. It is a hunting method that depends on genuine spatial reasoning about how another animal will move through a landscape under pressure, executed by two coyotes, coordinating that prediction together, a level of tactical planning that places this small, lean predator considerably closer to the sophisticated end of the animal kingdom's hunting playbook than its everyday reputation as an opportunistic scavenger would ever suggest. Here, the story turns from hunting towards something even harder to explain away as simple instinct evidence that coyotes appear capable of learning from observing outcomes they were not directly part of. Wildlife control specialists and researchers working in areas with active trapping programs have reported a recurring and frustrating pattern. Coyote activity noticeably decreasing around trap sites shortly after a trap has been triggered unsuccessfully or after another coyote has been caught and removed from the area, even in cases where the surviving coyotes had no direct physical contact with the trap itself. The leading explanation among researchers studying this pattern involves a combination of scent cues left behind by human handling of the trap site, and in some cases direct visual or auditory observation by nearby coyotes of another animal's distress during capture. Information that appears to get incorporated into the surviving animal's behavior going forward, without any need for first-hand experience of the trap themselves. This kind of observational avoidance learning, drawing a lasting behavioral lesson from watching or sensing another individual's negative experience, rather than only from direct personal consequence, is a relatively sophisticated form of learning, associated more commonly with primates and certain highly social mammals than with a mid-sized wild canid. It is part of why experienced trappers in coyote-heavy regions often describe a noticeable decline in trap effectiveness within a given area over the course of a single season. Not because the coyotes present have all been removed, but because the ones still present appear to have learned indirectly exactly what to avoid. This next behavior takes that observational caution and turns it personal, and it goes a long way toward explaining why poison-based control programs have historically struggled to maintain effectiveness against the same coyote population over time. A coyote that consumes a sublethal dose of poison bait and survives the resulting illness frequently develops what wildlife biologists term bait shyness, a strong and often lasting aversion to the taste, smell, or general appearance of whatever specific bait type caused the reaction, sometimes persisting for the remainder of that individual animal's life. This is not a uniquely coyote trait. The underlying mechanism, an animal forming a rapid, powerful aversion after a single unpleasant experience tied to something it ate, is a form of learning documented across a wide range of species and is generally understood to develop faster and more strongly than most other forms of learned avoidance, precisely because the evolutionary cost of getting food selection wrong even once can be severe. In coyotes specifically, wildlife managers running long-term poison control programs have observed declining bait uptake rates within populations that have already experienced previous exposure events, forcing periodic changes in bait formulation and presentation just to maintain any meaningful effectiveness against animals that have in effect already learned the lesson once. It is one more thread in the same pattern running through this entire stage of the coyote's story, an animal whose survival strategy leans heavily not on brute resistance to human control efforts, but on the simple, repeated act of learning quickly and remembering what it learns. Among trappers with decades of hands-on experience working coyote country, a particular story comes up often enough across different regions to be treated as more than isolated anecdote. Animals that appear to recognize the specific disturbed earth signature of a buried snare or foothold, trap, and either avoid the area entirely or, in some reported cases, deliberately dig around and expose the buried mechanism without triggering it. This behavior sits closer to the edge of what has been rigorously documented through controlled research compared to some of the other learning behaviors described earlier, and it deserves to be presented with appropriate caution rather than stated as settled scientific fact. Since much of the evidence comes from experienced field trappers' direct observation rather than from formal published studies. That said, wildlife researchers who study coyote cognition take these reports seriously rather than dismissing them outright, given how well they align with the more rigorously documented pattern of trap avoidance learning already described. What seems most plausible, based on the available evidence, is that coyotes are picking up on subtle visual and scent cues associated with human ground disturbance, freshly turned soil, faint residual scent from a trapper's hands or tools, and applying a general caution around those cues rather than specifically identifying a snare mechanism in any deliberate mechanical sense. Even framed conservatively, it points toward an animal paying close, sustained attention to exactly the kind of subtle environmental detail that a century of trapping pressure would have made worth noticing. Step back now from learning and toward something more fundamental to how this animal survives at all, because the coyote's dietary flexibility is in its own quiet way just as impressive as anything documented about its intelligence. Depending on season and local availability, a coyote's diet can shift dramatically, running as high as 90% meat and animal protein during winter months, when small mammals remain the most reliable food source, and swinging toward a diet dominated by fruit, berries, and other plant material during late summer and fall, when those foods become abundant and easier to obtain than actively hunting prey. Researchers analyzing coyote scat across different seasons and regions have documented this shift consistently enough to treat it as a defining feature of the species' feeding strategy, rather than an occasional exception, one of the widest dietary swings recorded in any North American predator of comparable size. This is not simply opportunistic scavenging, in the loosest sense of the term. It reflects genuine nutritional flexibility, a digestive system capable of processing both a heavily protein-based winter diet and a largely plant-based autumn diet without the kind of specialization that would leave a more narrowly adapted predator struggling when its preferred prey becomes scarce. That flexibility turns out to be one of the single most important factors behind the coyote's success across such a wide range of environments, an animal whose survival strategy has never depended on any one food source remaining reliably available. If you have ever walked out to a fall garden and found a watermelon split open and hollowed out overnight, or a row of squash mysteriously reduced to rinds, there is a decent chance the culprit was not a raccoon or a deer, but a coyote, working its way through the seasonal shift toward a more fruit and produce-heavy diet. Farmers and extension agents in coyote-heavy agricultural regions have documented coyotes raiding melon patches, squash plots, and fallen fruit from orchard trees with enough regularity that it has become a recognized, if somewhat overlooked category of seasonal crop damage in certain areas, alongside the more commonly discussed livestock predation described earlier in this story. The behavior tends to cluster tightly around late summer and early fall, exactly the window when wild fruit and berry sources begin to decline, heading into winter, and a coyote's foraging attention naturally turns toward whatever sweet, calorie-dense alternative happens to be available, cultivated or otherwise. There is something almost disarming about picturing the same animal capable of coordinating a deer hunt or slipping unseen past a studied fence line, spending a September evening instead methodically working through a row of garden squash, like a particularly determined and uninvited dinner guest. It is a small, oddly domestic image to sit alongside everything else in this story. A reminder that for all its predatory sophistication, the coyote remains at bottom, an animal simply looking for whatever the season happens to be offering closest at hand. Pull back from any single season, and the broader pattern behind that dietary swing becomes clear, because it is very likely the single most important reason the coyote has been able to establish itself in so many different environments across the continent. A predator locked into hunting one or two specific prey species is only as secure as that prey population vulnerable to any disease outbreak, habitat loss, or seasonal collapse that reduces its food source. The coyote carries no such vulnerability. Wildlife biologists comparing coyote survival rates across drastically different habitats, arid, desert, dense, eastern forest, coastal wetland, and now urban cityscape, have found the species maintaining viable populations in each one, largely because its feeding strategy simply does not depend on any single reliable food source remaining consistently available. Where a more specialized predator would face genuine crisis if its primary prey species declined sharply in a given region. A coyote facing the same circumstance simply shifts its foraging effort toward whatever alternative happens to be locally abundant that season. Rodents, fruit, insects, carrion garden produce, or unsecured human food waste. This is, in the most practical sense, the biological engine underneath everything else described in this story so far, the century of failed control programs. The continental range expansion, the successful colonization of major cities. An animal that can eat almost anything available in almost any environment starts every new challenge with an advantage most specialized predators simply do not have. Beyond simply eating whatever happens to be available, coyotes also practice a form of forward planning that many people would not expect from an animal typically pictured as living hunt to hunt. When a coyote encounters more food than it can immediately consume a surplus, kill a particularly productive foraging session, or scavenged carrion too large to finish in one sitting, it will often cache the remainder, digging a shallow hole and burying the excess food beneath soil leaves or snow to retrieve later once hunger returns. Researchers tracking individual coyotes have documented something more sophisticated still layered on top of this basic caching behavior. Animals that will relocate a cache to a new hiding spot if they have reason to believe the original site has been discovered or disturbed, whether by another coyote, a scavenging bird, or a human. This suggests the animal is not simply burying food on reflex and forgetting about it, but actively monitoring the security of its own stored resources and adjusting behavior in response to perceived risk. A level of ongoing resource management that requires the coyote to remember multiple cache locations, track how recently each one was created, and periodically assess whether a given site remains safe. It is a quiet, almost administrative piece of behavior compared to the drama of a coordinated deer hunt, but it points toward the same underlying pattern running through this entire portion of the story. An animal doing considerably more calculating, remembering and adjusting than its reputation as a simple opportunist ever suggested. Urban and suburban coyotes face a particular challenge that their rural ancestors never had to solve, learning to live in close proximity to a constant ongoing stream of human activity without either fleeing every time or just as dangerously for the species losing all wariness of people entirely. Researchers studying habituation patterns in urban coyote populations have found evidence of something more nuanced than either extreme animals that appear to distinguish between routine, non-threatening human activity, a lawnmower, running on a predictable schedule, joggers following a path at a consistent time, traffic noise from a nearby road, an activity that actually signals a real threat, a person approaching directly with intent, unfamiliar loud noises, or the presence of an off-leash dog. This kind of contextual risk assessment allows a coyote to remain functionally present and active within a landscape full of ordinary human activity without expending the energy or accepting the risk of reacting defensively to every single restraint, sound, and movement nearby. Wildlife officials view this distinction as genuinely important to healthy coexistence, since a coyote that has learned to correctly identify routine activity as harmless is somewhat counterintuitively often a safer neighbor than one that either panics at every disturbance or at the opposite extreme has become so comfortable around people that it loses appropriate caution entirely. Maintaining that middle ground, alert but not reactive, appears to require an ongoing, active process of sorting genuine threat from background noise, carried out continuously by an animal navigating a landscape its ancestors never had to interpret. This next detail, documented by researchers tracking urban coyote behavior on golf courses in California, offers one of the more specific and genuinely charming examples of that contextual learning in action. Coyotes denning near maintained golf courses have been observed adjusting their daytime resting and activity patterns around the predictable schedule of course maintenance equipment, moving away from areas about to be mowed shortly before the equipment arrives, and returning to favored resting spots once the noise and activity have passed a pattern consistent enough across multiple observation periods that researchers concluded the animals had genuinely learned the maintenance crew's routine timing, rather than simply reacting moment to moment to approaching noise. It is worth pausing here because there is something almost sitcom-worthy about picturing a wild predator capable of coordinating a deer hunt instead, spending its practical intelligence tracking the groundskeeper's Tuesday and Thursday mowing schedule with enough precision to plan its nap. Accordingly, the same animal that studies a suburban fence line for weaknesses, now treating a riding mower with all the practical caution most of us reserve for actual traffic. It is a small, almost domestic detail sitting inside a much larger story about adaptability, but it captures something essential about how this animal has managed to thrive in a human landscape, not through any dramatic confrontation, but through the quiet, unglamorous work of paying close attention and adjusting accordingly, one mowed fairway at a time. Return now to the question of learning and control, because this piece of research gets at something with real practical consequences for wildlife management. It is one thing for a coyote to learn to avoid a specific trap it has already encountered directly. It is a considerably more sophisticated feat for that same animal to apply the lesson learned from one trap design to a different trap it has never physically encountered before, based purely on some shared underlying cue. Field studies examining coyote responses to varied trap types within populations that had prior trapping exposure found evidence suggesting exactly this kind of generalization. Animals showing elevated caution around traps of an entirely different physical design or placement than the one that had originally triggered their avoidance. Learning provided the traps shared enough underlying similarity, human scent, disturbed ground, an unfamiliar object placed along a known travel route for the coyote to draw the connection. This kind of generalized learning, extracting an underlying principle from a specific experience and applying it more broadly to novel but related situations, represents a meaningfully more advanced cognitive process than simple direct association. And it is part of why wildlife management researchers have grown increasingly cautious about assuming that a new trap design will automatically outsmart a coyote population that has already learned to be wary of trapping efforts in decided general. The animal, it turns out, may not need to have seen your specific trap before to have already learned in a broader sense exactly what to be careful of. Set this stage's entire catalog of learning, flexibility, and behavioral adjustment against the fate of the large predators that once shared the coyote's range, and the contrast becomes genuinely stark. Gray wolves, mountain lions, and grizzly bears all faced comparable, or in some cases considerably less intense human persecution across the 19th and 20th centuries. And all three saw their North American ranges collapse dramatically. Wolves and grizzlies eliminated from the overwhelming majority of their historical territory, outside a handful of protected regions. Mountain lions pushed back largely into the western third of the continent. The coyote endured the same era of organized, well-funded eradication efforts, and came out the other side not diminished but expanded, occupying more territory at the end of the 20th century than it had held at the beginning. Wildlife biologists studying this divergence generally point to a combination of factors already laid out across this stage of the story. The compensatory reproduction described earlier, the dietary flexibility capable of sustaining the species through habitat and prey shifts that would starve a more specialized predator, and this less quantifiable but well-documented capacity for rapid behavioral learning, avoiding traps, timing traffic, and reading human routine closely enough to exploit it rather than simply fear it. Where larger, more specialized predators had few available adjustments to make in response to intensifying human pressure. The coyote, it turns out, had an entire toolkit of adjustments ready and used every one of them. There is a particular flavor of suburban frustration worth pausing on here. The gardener who spent a weekend installing a modest wire fence to keep rabbits out of the tomatoes, only to find the whole bed trampled and raided within the week by something considerably larger and more determined than any process. Rabbit. A fence built with rabbits in mind, low, lightweight wire designed to block a small animal working at ground level offers essentially no real obstacle to a coyote capable of clearing 5 feet of chain link in a single jump, or just as easily simply pushing through or under flimsier garden fencing without much effort at all. Extension offices in coyote territory report this exact scenario often enough each growing season to treat it as a recurring seasonal pattern rather than a one-off complaint. Gardeners who reasonably assumed their existing rabbit deterrent would handle any larger wildlife too, only to discover the two problems require entirely different solutions. The coyote in this scenario is not typically after the vegetables themselves in any deliberate sense, though the fall fruit rating described earlier shows it will happily eat produce when convenient. More often, it is drawn in by the same small mammals. The garden itself attracts rabbits and rodents feeding on the crop, with the coyote simply following that food source straight through a barrier that was never built with an animal its size in mind, leaving the actual vegetables as collateral damage in a hunt that had nothing to do with them in the first place. Ask around any neighborhood that has dealt with a persistent coyote problem, and you will hear a familiar chorus of contradictory advice. One household swearing by a 6-foot fence with an angled top extension, another insisting that same design failed within a month. A third convinced that motion-activated lights solved everything until the coyotes simply adjusted their route around the sensor's range. Wildlife officials fielding these comparisons regularly point out that the inconsistency itself is telling, not evidence that any particular fencing method is fundamentally flawed, but evidence of an animal individually assessing each specific barrier it encounters and finding whatever solution happens to work against that particular obstacle, rather than following any single universal workaround that would make one town's fix reliably transferable to the next yard over. A coyote that gives up on a well-built fence in one location might a few miles away encounter a nearly identical fence with one small gap in the foundation, and exploit it within days. Not because the second fence was meaningfully worse, but because that particular animal happened to find that particular weakness first. It leaves suburban homeowners in the odd position of comparing notes on an adversary that essentially refuses to be standardized, an animal whose adaptability, so impressive across the sweep of an entire continent, becomes a source of genuine neighborhood aggravation at the scale of a single backyard fence. One homeowner's solved problem, quietly becoming the next block's brand new one. Shift now toward the marvel of the coyote's life cycle itself, because the beginning of that cycle is about as vulnerable as life gets. A coyote litter typically numbers between 4 and 7 pups born after a gestation period of roughly 2 months, each one arriving blind, deaf, and almost entirely helpless, weighing barely half a pound, and utterly dependent on their mother from the first moment. There is nothing in that newborn state that hints at the animal it will become an efficient distance runner, capable of clearing a 5-foot fence, coordinating a deer hunt, or navigating a city's storm drains as a private highway system. For the first several weeks of life, a coyote pup exists in almost total darkness and silence, relying entirely on touch warmth and its mother's presence to survive, packed into a den alongside littermates in conditions that offer no margin for error. Biologists studying wild coyote reproduction have found litter size itself is not fixed, tending to run larger in years and regions where food is abundant and population density is lower, part of that same compensatory reproductive flexibility. Already described earlier in this story, a species capable of adjusting its own reproductive output in response to environmental and population pressure. It is worth holding this image for a moment before the story moves forward through the pup's development, because everything remarkable still to come, the sharpening senses, the rapid growth, the eventual independence, begins from exactly this fragile, unremarkable starting point. That fragile beginning takes place almost entirely underground, inside a den. A mother coyote, sometimes with help from her mate, will have prepared well in advance of giving birth. Coyote dens vary considerably, depending on available terrain, often dug directly into a hillside or embankment where the slope provides natural drainage and structural stability. Though coyotes will also readily use a hollow log, an expanded rock crevice, or particularly in developed areas, an abandoned burrow originally dug by a fox or badger, and simply enlarged to suit the coyote's own needs. A well-chosen den typically includes multiple entrances and internal chambers, offering both a safety margin in case one entrance becomes blocked or discovered, and enough space to accommodate a growing litter as the pups develop. Field biologists tracking denning coyotes have found that pairs frequently maintain more than one den site within their territory, sometimes relocating an entire litter to a backup den if the original site is disturbed by a predator flooding or human activity nearby, carrying pups one at a time in their mouths across distances that can run several hundred yards without apparent difficulty. This kind of contingency, planning an entire backup housing option prepared and ready before it is ever actually needed, is one more example of the same forward-looking behavior already documented in this animal's food caching habits. Extended here into the most consequential decision a breeding pair makes all year: where exactly to keep their offspring safe through the most vulnerable weeks of their lives. Once the pups arrive, feeding them becomes a coordinated family effort rather than a burden carried by the mother alone. The father coyote takes on a substantial and active provisioning role from the earliest days after birth, hunting and bringing food back to the den, so the mother can remain close to the pups during the period when they are most vulnerable and least able to regulate their own body temperature without her presence. As described earlier in this story, older siblings from a previous litter that have chosen to remain with the family group often join in this same effort, adding additional hunting capacity to a family unit now responsible for feeding several extra mouths. Researchers observing this provisioning behavior have documented adult and yearling coyotes returning to the den, carrying prey items ranging from small rodents to larger game, sometimes partially consumed and regurgitated for the youngest pups not yet capable of handling solid food, a feeding strategy shared broadly across canid species that allows very young pups to begin transitioning toward meat consumption well before they are physically able to hunt or even chew effectively on their own. This entire cooperative structure, mother nursing and guarding father and any helper siblings hunting and provisioning, represents a genuinely demanding logistical operation sustained over a period of weeks, and it stands as one of the clearest practical demonstrations of just how much the coyote's family-oriented social structure, already described earlier in this story, matters to the actual survival of the next generation. Somewhere around the 3-week mark, a coyote pup takes its first uncertain steps out of the darkness it has known since birth, blinking into daylight for what is in most cases the very first real look at the world beyond the den. Entrance. By this point, the pup's eyes have opened its legs, have gained enough strength to support brief wobbling movement, and its senses have developed to the point where the outside world, full of sound, scent, and light the den never offered, becomes something it can begin to actually process rather than simply endure. Wildlife researchers, observing dens during this period, describe a fairly consistent pattern, pups venturing just a short distance from the entrance at first, staying close enough to retreat quickly at any sign of disturbance, gradually extending that range over the following days and weeks as both confidence and physical coordination improve. This is also typically the point at which a den site becomes visually detectable to a careful outside observer for the first time. Small tracks in the dirt near the entrance warn patches of vegetation. Occasional glimpses of pups tumbling over each other in play just outside the opening, though a responsible observer keeps well back, given how protective a denning mother can become, as already described earlier in this story. It marks a real turning point in the pup's development. The transition from an entirely den-bound existence toward the beginning of an active engagement with the world it will spend the rest of its life navigating. The pace of development from that first cautious step outside the den accelerates considerably over the following weeks. By roughly 10 weeks of age, young coyotes have typically progressed from brief exploratory ventures near the den entrance to genuine short-distance travel alongside adult family members tagging along on hunting expeditions, territorial patrols in a supervised, gradually expanding capacity that lets them begin absorbing the practical skills they will eventually need as independent adults. These early excursions are not yet full participation in the kind of coordinated hunting behavior described earlier in this story, but researchers observing family groups during this period note young coyotes clearly attentive to adult behavior during these trips, watching hunting attempts, investigating scent marks left by other coyotes, and beginning to learn the physical boundaries and important features of their family's territory firsthand rather than only through instinct. It is a critical stretch of practical education, compressed into a remarkably short window given how much a young coyote will need to know by the time it eventually disperses to establish territory of its own, and it depends entirely on the sustained parental and sibling investment. Already described across the preceding several facts, an entire family structure oriented around preparing this next generation for a level of independence and survival skill that arrives on a genuinely compressed timeline compared to many other mammals of comparable size. That compressed timeline reaches its natural conclusion sooner than most people would expect. The majority of young coyotes leave their birth territory and strike out on their own before completing their first full winter, typically departing sometime between 6 and 9 months of age. A pace of independence considerably faster than most people would assume for an animal this socially and behaviorally sophisticated. This dispersal is not simply a passive drift away from the family group. It is generally understood by researchers as an active, often somewhat abrupt departure, sometimes coinciding with increased tension from parents as the following year's breeding season approaches, and available territory and resources within the family's home range grow tighter with an additional generation now old, enough to compete for them directly. Not every young coyote disperses on this same rapid schedule, and the helper-sibling behavior already described in this story shows some individuals delaying that departure by a full additional year to assist with a subsequent litter instead. But for the majority, this remains the pattern. A young animal born blind and helpless in an underground den just months earlier, now facing the prospect of finding, claiming, and defending entirely new territory of its own, often without the benefit of the extended family support system that raised it. It is a striking pace of forced independence, and it sets up directly the next stage of this story, because what a young coyote does next, once it actually leaves, turns out to be just as remarkable as everything that came before it. Once that departure happens, a young coyote does not simply wander to the next available patch of unclaimed ground nearby. Researchers tracking dispersing juvenile coyotes with radio collars have documented individual animals traveling well over 100 miles from their birth territory before finally settling into new ground. A journey covering terrain the young animal has never encountered before, crossing unfamiliar rivers, roads, and the territories of other established coyote families, along the way entirely without the guidance or protection of the family group that raised it. To put that distance in terms that land with real weight, 100 miles is roughly the driving distance between many mid-sized American cities and their nearest major metropolitan neighbor, a trip most people would plan around on a map and complete in a few hours behind the wheel, undertaken instead on foot alone by an animal not yet a year old, navigating entirely by instinct, scent, and whatever practical lessons it managed to absorb during those brief months of family-supervised travel described in the previous fact. Not every dispersing coyote travels anywhere near that far, and plenty settle into new territory within a much shorter range of their birth site if suitable unclaimed ground happens to be available closer to home. But the documented cases of animals covering well over 100 miles illustrate something important about the underlying capability driving the species' continental expansion. Already described earlier in this story, individual young coyotes possessing both the physical stamina and the apparent determination to simply keep moving until they find ground worth claiming. Hold that image of a single young coyote covering 100 miles alone, and now multiply it across roughly a century of successive generations, doing essentially the same thing, because that accumulated pattern of dispersal is precisely what turned the coyote from a regional western animal into a continental one. At the dawn of the 20th century, the coyote's range was largely confined to the open plains, prairies, and desert regions west of the Mississippi River, the territory most Americans still picture by default when they hear the word coyote, tumbleweed, and open horizon, rather than rail corridors and cemetery grounds. East of that river, the coyote was essentially absent, a species genuinely restricted to the western half of the continent in a way that would have made the animal's eventual presence in Boston, Manhattan, and the Florida Everglades seem to any wildlife observer of that era like a fairly wild speculation. That starting point matters enormously for understanding everything that follows in this stage of the story, because the transformation from that regional range into the truly continental presence the coyote holds today did not happen through any single dramatic event, an introduction program, a deliberate relocation, or any human intervention at all. In Wittenbiter in Tembled Y, it happened the way the previous fact described, one dispersing young coyote at a time, generation after generation, each one pushing the edge of the species' range a little further than the last, until the map itself looked nothing like where the story had started. By the time researchers sat down to map the coyote's range at the close of the 20th century, the transformation from that western starting point was almost impossible to overstate. Within roughly 100 years, a span shorter than a single human lifetime stretched to its outer limit. The coyote's range expanded from its original western confines to cover nearly the entire North American continent, from the Pacific coast to the Atlantic seaboard, from the subarctic reaches of Alaska and northern Canada down through Mexico and into Central America. Wildlife biologists studying large-scale range shifts across mammal species generally describe changes of this magnitude as occurring over evolutionary timescales, thousands of years of gradual adaptation and migration, not the handful of generations the coyote actually required. What makes the pace even more remarkable is the context already established across this entire story. This expansion happened not in the absence of resistance, but directly through the teeth of it unfolding during the exact same century as the most sustained predator eradication campaign in American history. Researchers who study the phenomenon now generally treat the coyote's range expansion as one of the fastest and most successful of any wild mammal recorded on the continent in modern times, a distinction that sits at odds with everything the extermination programs described earlier in this story were actually designed to accomplish. The animal did not simply survive the century. It used it to become something considerably larger geographically than it had ever been before. Numbers alone struggle to convey what a continent-spanning range expansion actually looks like, so it helps to put it in terms an American listener can genuinely picture. The distance from the Pacific coast of California to the Atlantic coast of Maine runs somewhere in the neighborhood of 3,000 miles as the crow flies. The coyote's range expansion over the past century did not simply add a single corridor of that length. It filled in territory across the entire width and breadth of that distance, and beyond it, north into Alaska and south through Mexico, an area that laid end to end in coast-to-coast increments, would require crossing the continental United States many times over just to trace its outer boundary once. This is not a single population slowly drifting eastward in a tidy line on a map. It represents countless individual dispersal events, each one similar in scale to the 100-mile journey described earlier in this story, layered on top of each other across generations and across every compass direction simultaneously, gradually filling in a landmass that most wildlife biologists a century ago would have confidently predicted was permanently beyond this particular animal's reach. Picture every interstate highway crossing the lower 48 states, every regional map boundary separating one state's wildlife agency from the next, and understand that somewhere within essentially all of that territory today, a coyote is very likely denning, hunting, and raising pups within a landscape that when this century began had never known the species at all. Given a range expansion of that scale, the natural next question is simply how many coyotes that territory now actually holds, and wildlife researchers offer a figure worth treating with appropriate care rather than false precision. Because coyotes are spread across such an enormous and varied landscape, urban, rural, and wilderness alike. With no single unified continental census effort tracking the species the way certain endangered animals are monitored, any total population figure necessarily rests on regional estimates, extrapolated outward rather than a direct, comprehensive count. With that caveat clearly stated, the general consensus among wildlife biologists places the total North American coyote population somewhere in the range of several million animals, a figure large enough that it likely exceeds the historical peak population, the species, held even within its original more limited western range before the 20th century's control campaigns and range expansion both began. It is worth sitting with the strangeness of that fact for a moment. A species targeted by one of the most sustained lethal control efforts ever directed at a North American mammal may well be more numerous today across a vastly larger territory than it was before that effort ever started. Researchers studying the coyote's population trajectory generally treat this outcome not as a mystery requiring further explanation, but as the direct, logical result of everything already described across this story: compensatory, reproduction, dietary flexibility, rapid learning, and a dispersal drive capable of carrying the species into territory it had never previously called home. Zoom back in from the continental scale to a single pair of coyotes arriving in genuinely new territory, because the mathematics of how quickly that founding pair can establish a substantial local population is on its own worth pausing over. A single mated pair settling into unclaimed territory with adequate food and denning sites can, within the span of just a few breeding seasons, to produce a local population, numbering well into the dozens, accounting for successive litters averaging 4 to 7 pups each year, a portion of those offspring remaining as helper siblings for a season before eventually dispersing themselves to found entirely new territories of their own nearby. Wildlife biologists modeling coyote population growth in newly colonized regions have found this compounding effect, each generation producing its own dispersing offspring, who go on to found additional new territories within just a year or two of their own birth, capable of transforming a single founding pair into an established, self-sustaining regional presence within a remarkably short window, often well under a decade from that very first pair's arrival. This is essentially the same mechanism responsible for the entire continental expansion already described in this story, simply observed at the scale of an individual town or county rather than the whole of North America. And it explains something that puzzles a lot of longtime residents who recall a coyote-free landscape from their own childhood, and now, within the span of a single generation, share their neighborhood with an established breeding population that seemingly appeared out of nowhere. For all the resilience and adaptability documented across this entire story, an individual coyote's life in the wild remains genuinely short and hard, and it is worth stating that plainly before this stage turns toward the more optimistic side of the coyote's life cycle. Wildlife researchers tracking wild coyote populations generally place average lifespan somewhere between 6 and 8 years, a figure shaped heavily by the accumulated hazards this story has already laid out. Vehicle strikes on roads the species has learned to navigate but not eliminate risk. From entirely disease starvation during lean seasons despite the dietary day, flexibility already described territorial conflict with other coyotes, and still the ongoing lethal control programs covered earlier in this story that continue in various forms today. Pup mortality in particular runs high, with a substantial portion of any given litter failing to survive its first year even under favorable conditions, a hard biological reality that sits directly behind the compensatory reproduction strategy already described. Larger litters and earlier breeding age serving in part as a direct response to exactly this kind of steep early mortality. It is a sobering note to place alongside everything else in this story, a reminder that the coyote's remarkable success as a species has never meant an easy or particularly long life for any single individual animal within it. Survival, at the population level, built, in no small part, on the sheer volume of new life produced each year against genuinely difficult odds. Remove those wild hazards entirely, and the coyote's biological ceiling looks considerably different. Coyotes held in captive settings, zoos, wildlife rehabilitation facilities, and research programs regularly live well past their 14th birthday, with some individual animals documented reaching close to 20 years of age under consistent veterinary care, reliable nutrition, and freedom from the vehicle strikes starvation risk and lethal control programs that shorten the average wild lifespan so significantly. This gap between wild and captive lifespan is not unusual among wild mammals broadly, But the scale of it in the coyote's case is worth noting precisely because it underscores just how much of the 6 to 8 year average lifespan described in the previous fact reflects environmental hazard rather than any fundamental biological limit on how long this particular animal is actually capable of living. A coyote in captivity is in a very real sense the same animal, carrying the same senses, the same intelligence, and the same physical capability described across this entire story, simply operating without the constant accumulated risk that wild coyotes navigate every single day of their lives. It offers a useful, clarifying lens on everything else in this story. A reminder that the coyote's success as a species has never been about individual animals living especially long or especially easy lives, but about a species-level strategy built to absorb enormous individual loss and keep producing enough new life to more than compensate for it. Set those two lifespan figures directly against each other and the difference becomes genuinely striking rather than simply notable. A wild coyote averaging 6 to 8 years and a captive coyote regularly reaching 14 or beyond represents nearly double the lifespan achieved through nothing more dramatic than the removal of the specific daily hazards already described across this story. No medical intervention, extending some fundamental biological limit, no genetic difference between the populations, simply the absence of starvation, risk vehicle traffic, territorial violence, and lethal human control efforts that a wild coyote navigates as a basic condition of its everyday existence. It is worth comparing this gap to something more familiar for a moment of scale. Human life expectancy, in regions with reliable access to modern medicine, clean water, and basic safety, runs meaningfully longer than in regions lacking those same protections. A difference driven by comparable underlying logic, environmental hazard shortening a lifespan that biology alone would otherwise allow to run considerably longer. The coyote's captive versus wild gap tells much the same story, compressed into a single species and measured in years rather than decades. Every wild coyote loping across a field or slipping through a suburban yard is in effect living inside a considerably more dangerous set of daily circumstances than its own biology would technically require. A full second lifetime's worth of years quietly available to the species, just out of reach of almost every individual actually living it. Territory size for an established coyote varies enormously depending on habitat, and that variation itself tells a useful story about how directly this animal's range requirements track available food and shelter. In open resource-sparse country, a single family group's territory can extend across 20 square miles or more. A range large enough that patrolling and defending its full boundary requires the kind of sustained travel and endurance already described earlier in this story, those long legs built for distance covering genuinely significant ground on a regular basis, simply to maintain the family's claim over it. In food-dense, resource-rich environments, by contrast, territory size can shrink dramatically, sometimes down to just a few square miles or less. A family group, finding everything it needs within a considerably tighter radius and having little practical reason to defend or patrol anything larger. Researchers tracking territory size across different coyote populations have found this variation correlates most strongly with food availability and density of other coyote families, competing for the same general area rather than with any fixed, universal territorial instinct, dictating a set range, regardless of local conditions. It is one more expression of the same underlying flexibility that has defined nearly every stage of this story so far. An animal whose fundamental habits, diet, activity, timing, denning strategy, and now territory size itself adjust readily to whatever a given landscape actually offers rather than insisting on a single fixed template regardless of where it happens to find itself. That same food-driven territory principle plays out with particular clarity in cities where researchers tracking radio-collared urban coyotes have documented some of the smallest territory sizes recorded anywhere within the coyote species range, occasionally just a handful of square miles. Or even less, for a family group settled into a resource-rich pocket of green space, with reliable access to prey, water, and the kind of overlooked human food sources already described earlier in this story. This tight packing has a direct consequence. Worth noting, urban and suburban landscapes capable of supporting a meaningfully higher density of coyote families per square mile than would ever be sustainable in the open, resource-sparse country, where the 20 square mile territories described in the previous fact become necessary just to secure adequate food. It helps explain something that often surprises residents first learning just how many coyotes actually share their city. A population that can seem impossibly dense for an urban environment starts to make considerably more sense once the underlying territory math is laid out plainly. A golf course, a cemetery, a well-vegetated stretch of rail corridor, all already described earlier in this story as favored urban habitat. can each support a family group needing only a fraction of the range an equivalent group would require out on open prairie. The city in this narrow but genuinely important sense offers the coyote something close to abundance, and the species has organized its territorial behavior accordingly, tighter, denser, and considerably more numerous per square mile than most residents walking those same streets would ever guess. Return briefly to the pup described earlier in this story, born blind and entirely dependent on touch and warmth alone, because the timeline of that early sensory development is worth tracing a little further. A coyote pup's eyes remain closed for roughly the first 10 to 14 days of life, sealed shut in the same way most newborn canid species are born, before finally opening to reveal a world the pup has, until that point, experienced only through scent sound muffled by the den walls and direct physical contact with its mother and littermates. Once open, a pup's eyesight develops rapidly over the following days and weeks, moving from an initial blurred, unfocused state toward the kind of functional vision that will eventually support the extraordinary night vision and sharp directional awareness already described earlier in this story as defining features of the adult coyote's sensory toolkit. Biologists studying early canid development note that this delayed eye-opening likely reflects a broader evolutionary pattern found across many mammal species, born in a genuinely helpless altricial state, prioritizing rapid physical growth and a protected den environment during the earliest and most vulnerable days of life over the kind of immediate sensory readiness that a more precocial newborn species, capable of standing and moving shortly after birth, would require instead. It is a small, easily overlooked detail, but it marks the literal moment a coyote pup's world expands from touch and sound alone into something it can finally, for the first time, actually see. Trace the full arc from that blind half-pound newborn through everything already described across this entire life cycle stage of the story. The den, the first steps outside. At 3 weeks, the early travel alongside adults at 10 weeks. The dispersal before the first winter even ends, and the timeline that emerges is genuinely remarkable for its speed. Within roughly a single year of birth, a coyote reaches essentially full adult size, full physical capability, and in most cases has already left its birth territory entirely to begin the search for new ground of its own. A search that, as already described earlier in this story, can carry a young animal well over 100 miles from where it started. Compare that pace to a large domestic dog of comparable adult size, which typically continues physical development well past its first birthday and remains dependent on human care throughout. And the coyote's compressed timeline stands out even more sharply. Wildlife biologists studying canid development generally attribute this accelerated maturation directly to the harsh realities of wild survival, already laid out across this story: the short average lifespan, the high early mortality rate, and the genuine necessity of reaching full independence quickly in an environment offering no guarantee of ongoing parental support beyond that first year. There is no leisurely adolescence built into this animal's biology. Survival demands readiness on a timeline measured in months rather than years, and the coyote's development has been shaped, generation after generation, to meet exactly that demand. Step back now and hold the entire arc of this stage together in a single frame, because it deserves a moment of genuine reflection before this story moves toward its final chapter. A creature that begins life blind, deaf, and barely half a pound, utterly dependent on a mother's warmth inside a hillside den, becomes within the span of a single turn of the seasons, an animal capable of everything already documented across this entire story, coordinating a hunt against prey many times its own size, navigating a city's storm drains as a private highway system, reading the timing of a golf course mower, remembering the location of buried caches, and covering more than 100 miles of unfamiliar terrain entirely on its own in search of new ground to call home. That is not a gradual, decades-long unfolding of capability the way it would be in a longer-lived, slower maturing mammal. It is a complete transformation, compressed into roughly 12 months, spring to spring. One winter closing a chapter that began in an entirely different animal altogether. There is something worth sitting with in that pace, a reminder that the sophistication documented across nearly every stage of this story so far, the intelligence, the learning, the physical capability, was never something the coyote grew into, slowly over a long protected childhood. It was built fast, out of necessity in a single year. And it is worth carrying that image forward into this story's final turn, because what remains to be covered now is not what the coyote can do, but what it actually means both to the world it shares and to the small handful of questions about it that science still has not fully answered. Every species occupies a particular role within its ecosystem, and understanding the coyote's place in that larger picture means returning once more to the gray wolf, an animal already referenced several times across this story for the genetic legacy it left behind in eastern coyote. populations. Wolves once served as the continent's dominant mid to large predator across an enormous range, exerting real, measurable pressure on deer, elk, and other large herbivore populations, pressure that shaped everything from vegetation patterns to the behavior of the prey species themselves. As wolves were eliminated from the overwhelming majority of that range through the same century of persecution already described in this story, that ecological role did not simply vanish along with the animal that had filled it. Ecologists studying predator dynamics across North America have documented the coyote gradually stepping into significant portions of that vacated niche, particularly in regions where wolves are now entirely absent, exerting its own, somewhat different but genuinely comparable pressure on deer and other prey populations, a role reinforced in the eastern portion of the continent by the larger body size and stronger jaw structure already described earlier in this story as a direct legacy of wolf-coyote interbreeding. It represents one of the more striking examples in modern North American ecology of a functional role within an ecosystem, persisting even after the species originally responsible for it has been almost entirely removed, filled instead by a smaller, more adaptable relative that simply expanded to meet the gap left behind. Set aside the deer and elk dynamics for a moment, because the coyote's more consistent day-to-day ecological contribution happens at a considerably smaller scale, and it is one that benefits American agriculture directly, even as the livestock predation described earlier in this story creates real, ongoing tension with the same farming communities. Rodents and rabbits make up a substantial and consistent portion of the coyote's diet across nearly every season and region already described in this story. And ecologists studying predator-prey dynamics in grassland and farmland ecosystems have found that healthy coyote populations exert genuine, measurable downward pressure on these smaller mammal populations, pressure that, left unchecked by any predator at all, can translate into significant crop damage and grassland degradation from unrestrained rodent and rabbit population growth. Agricultural researchers examining regions where coyote populations were significantly reduced through the control programs already detailed earlier in this story have in some cases documented a corresponding rebound in rodent activity associated crop damage, an outcome that runs directly counter to what those same control programs were originally intended to protect. It is a genuinely complicated relationship to sit with honestly an animal responsible for real documented livestock losses that ranchers have every right to resent, while simultaneously providing a form of pest control that likely saves American agriculture meaningful money each year through rodent suppression alone. Two sides of the same predator that rarely get weighed against each other in the same conversation. Push that rodent suppression role one step further into concrete farm-level terms, because the connection between coyote presence and crop protection is not simply theoretical. Agricultural studies examining fields and grasslands with active healthy coyote populations nearby have found measurably lower rates of rodent-related crop damage compared to similar agricultural land where coyote presence has been significantly suppressed through control efforts, a pattern consistent enough that some agricultural researchers now frame coyote presence as a genuine, if largely unrecognized, form of natural pest management running alongside more conventional approaches. Picture a farmer's field of corn or wheat, and picture the difference between a modest, tolerable level of rodent grazing damage around the field's edges versus the kind of unchecked population explosion that can occur when the entire local predator base has been removed. An explosion capable of meaningfully reducing yield across a much larger portion of the crop rather than just its margins. That difference multiplied across the scale of American farmland broadly represents real economic value delivered by an animal whose relationship with agriculture is far more often discussed in terms of the livestock losses already detailed earlier in this story than in terms of this quieter offsetting benefit. It does not erase the genuine cost coyotes impose on ranchers raising sheep and calves, a cost this story has never tried to minimize. But it does complicate the picture considerably, suggesting the coyote's actual net relationship with American agriculture is more balanced and more interesting than either side of that argument typically acknowledges on its own. There is a further layer to the coyote's ecological role that becomes visible specifically when the animal is removed from a given landscape rather than simply observed within one. And it involves a phenomenon ecologists call mesopredator release. As the dominant mid-sized predator across much of its range, particularly in regions where wolves and mountain lions are absent, the coyote exerts real suppressive pressure on smaller predators, sharing the same territory: foxes, raccoons, skunks, and feral or outdoor domestic cats, among them through a combination of direct predation competition for the same food sources and simple territorial exclusion. Ecologists studying regions where coyote populations were significantly reduced through the control programs already described throughout this story have documented a corresponding surge in these smaller predator populations once that suppressive pressure was removed, foxes and other mid-sized predators expanding rapidly into territory and resources the coyote had previously monopolized. This creates a genuinely counterintuitive outcome worth sitting with. Directly an effort aimed at reducing predation pressure on a landscape by removing coyotes. Can through this mesopredator release effect actually increase overall predation pressure on certain vulnerable prey species simply, shifting which predator is doing the hunting rather than reducing predation itself? It is one of the clearer illustrations in modern wildlife ecology of how removing a single species from an ecosystem rarely produces the simple, isolated effect that removal was originally intended to achieve, rippling instead through a web of relationships considerably more tangled than a single predator-prey relationship alone. Follow that mesopredator release effect one step further, because the ripple does not stop with the smaller predators themselves. Foxes, raccoons, and other mid-sized predators that expand into territory once suppressed by coyote presence tend to prey heavily on ground-nesting birds, their eggs, and small game species, a category of prey that coyotes themselves consume far less consistently than these smaller, more specialized nest predators do. Ecologists studying songbird and game bird populations in regions affected by this kind of mesopredator release have documented measurable declines in nesting success tied directly to the expansion of fox and raccoon populations following coyote suppression, an outcome that sits in genuine tension with the original goal of many historical coyote control programs, which were rarely aimed at protecting ground-nesting birds in the first place, but produced this consequence anyway entirely as an unintended side effect. It creates a strange kind of ecological irony worth holding on to. An effort to reduce one predator's impact on a landscape, ultimately increasing the total predation pressure on an entirely different set of vulnerable species that were never the original target of concern at all. Wildlife managers who study these cascading effects now generally treat coyote presence, complicated as its relationship with agriculture and pets already described in this story clearly, is as playing a genuinely stabilizing role for certain bird populations, specifically because of the pressure it keeps on smaller nest predators. One more thread in an ecological relationship, considerably more tangled than the simple predator versus livestock framing this animal is most often reduced to. Step now from ecology into culture, because the coyote's place in the American story runs considerably deeper than the century of control programs and suburban encounters already covered throughout this narrative. Long before European settlement reshaped the continent, the coyote held a significant and recurring place in the oral traditions of many Native American peoples across the western and southwestern regions of North America, most prominently as a trickster figure, a character defined by cunning, mischief, and a habit of getting into trouble through its own cleverness. These trickster stories varied considerably from one nation and tradition to the next, and it would be a mistake to flatten them into a single uniform narrative, but the coyote's recurring role across so many distinct storytelling traditions speaks to just how closely observed this animal already was by the people who shared the landscape with it for thousands of years before written records of North American wildlife began. Anthropologists and folklorists studying these traditions note that the coyote character typically embodies a particular kind of intelligence, clever enough to manipulate situations to its advantage, but often undone by its own greed, arrogance, or impulsiveness, a narrative arc that carries genuine moral and cultural weight within the traditions that produced it, rather than functioning as simple entertainment alone. It is worth recognizing that the qualities so thoroughly documented across this entire story, the intelligence, the adaptability, the persistent cleverness in the face of obstacles, were already understood and woven into story by people living alongside this animal centuries before any wildlife biologist ever radio-collared one. Look more closely at the shape these trickster stories typically take, and a consistent pattern emerges across many different traditions. One that reads almost like an early, intuitive understanding of exactly the behavioral complexity this entire story has spent so much time documenting. The coyote of traditional storytelling is rarely simply clever in an uncomplicated, admirable sense. It is just as often greedy, overconfident, or too eager to exploit a clever scheme past the point where restraint would have served it better, and that overreach frequently becomes the very thing that undoes it by the story's end, tricked, in turn, by an animal or circumstance it underestimated, or, caught by consequences its own cleverness failed to anticipate. Folklorists studying this pattern across multiple traditions note that it gives the coyote character a genuinely complex moral shape, rarely found in simpler animal fables, neither purely wise nor purely foolish, but something closer to recognizably, believably flawed, clever enough to repeatedly get itself into difficult situations, and clever enough, often just barely, to find its way back out of them. There is something worth noticing in how closely that narrative arc mirrors the actual documented behavior already covered. Throughout this story, an animal whose intelligence and adaptability are real and well established, but whose opportunism raiding a henhouse past the point of any practical need, already described earlier in this story, or pushing into a suburban yard where discovery becomes almost inevitable, carries exactly that same flavor of cleverness, occasionally outrunning good judgment. That trickster reputation formed centuries before wildlife biology had any formal vocabulary for describing coyote behavior, has never actually faded from the way Americans talk about this animal, even now in an era of radio collars and camera trap footage. The language used throughout this very story, cunning survivor, an animal that studies a fence line, that learns a mower's schedule, that outlasts every effort aimed at eliminating it, echoes the same basic character established in trickster storytelling long before any of the modern research already described in this story existed to confirm it. Cultural historians studying how American attitudes toward wildlife have evolved note that the coyote occupies a genuinely unusual position among North American predators, specifically because of this deep cultural layering, an animal that carries both the earlier reputation of clever survivor, inherited from indigenous storytelling traditions, and layered on top of that a more recent, complicated identity as suburban nuisance, livestock threat, and unexpected urban neighbor all at once. Few other American animals carry quite that same combination of old folklore and current lived experience reputation running simultaneously and reinforcing each other. The modern homeowner swapping stories about a coyote's fence-testing persistence, unknowingly echoing a storytelling tradition stretching back long before that homeowner's own ancestors ever set foot on the continent. It is a genuinely rare thing, an animal whose character established in stories centuries ago turns out to hold up remarkably well against everything modern science has since confirmed about how it actually behaves. Bring this story back for a moment to the present tense, because the century of control efforts already documented throughout this narrative is not in fact history, in the fully settled sense that word usually implies. Government-funded lethal control programs targeting coyotes remain active in parts of the country today, continuing through federal wildlife damage management agencies working in cooperation with state governments and agricultural interests, employing many of the same basic methods already described earlier in this story: trapping, aerial, gunning, and targeted removal efforts focused primarily on protecting livestock in ranching-heavy regions of the American West. These programs operate at nowhere near the scale of the historical bounty and poison bait campaigns detailed earlier in this story, and modern wildlife management has moved meaningfully away from some of the more indiscriminate methods, like the widespread compound 1080 poisoning, already described, that caused significant collateral damage to non-target species in decades past. But the underlying premise, lethal removal as an accepted ongoing tool for managing coyote impact on livestock, remains firmly in place across significant portions of ranching country, funded by public money and defended by many within the agricultural community as a necessary, if imperfect, response to real and ongoing economic loss. It is worth stating plainly that this story's opening chapter was never simply describing a closed historical episode. The war against the coyote, considerably reduced in scale and method from its 20th century peak, is still in a real and active sense being waged today. Set directly against that ongoing lethal control effort sits an entirely different and considerably newer approach unfolding simultaneously across many American cities and suburbs. Municipal wildlife agencies, park departments, and university extension programs in coyote-populated urban and suburban areas now commonly run public education initiatives focused explicitly on coexistence rather than elimination, teaching residents practical, non-lethal, two strategies already touched on throughout this story: securing garbage and pet food, supervising small pets during dawn and dusk hours, and recognizing the difference between a healthy, appropriately wary coyote and one that has become dangerously habituated to human presence. These programs generally start from a premise that stands in real contrast to the control program logic still active in ranching country, an acceptance that coyotes are now a permanent, established feature of most American landscapes, urban and rural alike, and that the more realistic and effective goal is managing how humans and coyotes share that space, rather than attempting anything resembling elimination, an approach this entire story has already demonstrated conclusively does not work at any sustained scale. Wildlife educators running these programs report a gradual but genuine shift in public attitude in many of the cities where they operate. Longest residents moving from reflexive fear or hostility toward a more informed, practical wariness that treats the coyote less as an invading threat and more as an established neighbor, requiring the same basic common sense any wild animal sharing close quarters with people would require. Hold both of those realities in view at once, because their simultaneous existence says something genuinely important about where this story actually stands today, rather than where it began or where it might eventually end up. In the very same present moment, the United States is home both to active, government-funded lethal control programs still targeting coyotes across ranching regions of the West, and to public education campaigns in major cities, actively encouraging peaceful coexistence with that same species, two fundamentally different philosophies toward the identical animal, operating side by side, sometimes within the same state, without any single unified national policy attempting to reconcile them. This is not a contradiction so much as it is an honest reflection of how genuinely complicated the coyote's actual relationship with this country has become. An animal capable of costing a rancher real income through livestock predation, while simultaneously providing measurable rodent control benefits to a farmer, a county over capable of raiding a suburban chicken coop, while also denning quietly for years in a city park, without a single resident ever noticing. There is no tidy resolution to offer here, and this story has no interest in manufacturing one where the evidence itself does not support it. The coyote story in America right now is a genuinely split, one hunted in one region and studied with something close to public affection in another, and both of those things are simultaneously currently true. As this story turns toward its final questions, it is worth returning to the wolf ancestry already documented earlier, because the full extent of that genetic legacy remains even now an active area of ongoing research rather than a settled matter. Geneticists continue mapping exactly how far wolf-derived DNA has spread through eastern coyote populations, tracking regional variation in ancestry percentage from New England down through the mid-Atlantic states and into the southeastern United States, where coyotes arrived more recently and where the degree of historical overlap with remnant wolf populations, and therefore the opportunity for interbreeding, differed considerably from the pattern already described earlier in this story for the Northeast. Researchers are also working to understand whether that wolf ancestry is stable across generations or gradually diluting as eastern coyote populations continue interbreeding primarily among themselves rather than with any remaining wolves. A population that, as this story has already made clear, exists today only in a small handful of protected regions with very limited opportunity for further direct contact. The genetic tools available to answer these questions have improved dramatically over just the past 2 decades, and researchers studying eastern coyote populations now routinely uncover finer-grained detail than was possible even 10 years ago about exactly how, when, and where that original wolf-coyote interbreeding actually occurred. It remains a genuinely open area of study. One more reminder that even a trait as fundamental as this animal's own genetic makeup is still in a real sense being actively written and rewritten into the scientific record. Beyond simply mapping where that wolf ancestry currently exists, a further and genuinely unresolved question hangs over what happens to it moving forward. Population geneticists studying eastern coyote populations are still working to understand whether the wolf-derived genetic material already documented throughout this story will persist at meaningful levels across future generations, gradually dilute toward negligible presence as eastern coyotes continue breeding overwhelmingly with other coyotes rather than any remaining wolves, or potentially even increase in certain traits, if those wolf-derived characteristics, larger body size and stronger jaw structure among them, confer some ongoing survival or reproductive advantage worth natural selection favoring over successive generations. This is a genuinely open question, rather than one with a confidently predicted outcome, and researchers studying it are careful to avoid overstating what current data can actually support. Since tracking genetic change across wild populations over multiple generations requires exactly the kind of long-term sustained study that has only become methodologically possible in recent years. What makes the question matter beyond simple scientific curiosity is the broader pattern it represents, a live, ongoing example of evolutionary change happening in a wild North American mammal population in real time, observable and trackable by scientists working today, rather than reconstructed after the fact from fossil or historical evidence alone. Whatever the eventual answer turns out to be, the coyote currently loping through a New England forest is carrying within its own DNA a genuinely unresolved scientific question that researchers are still actively working to answer. Return finally to the question of intelligence itself, because for all the documented learning behavior already covered across this story, trap avoidance, generalized caution, route memory, through city infrastructure, cached food, monitored, relocated researchers studying coyote cognition are still working to understand the genuine upper limit of what this animal is actually capable of, and how that capability compares more precisely to other intelligent mammals already well studied in controlled settings. Much of the most striking evidence already described throughout this story comes from field observation, rather than the kind of tightly controlled cognitive testing. Researchers, dogs, and various primates, and scientists studying coyote intelligence are candid about the gap that creates real, well-documented behavior in the wild that strongly suggests sophisticated problem-solving and memory, without yet the same depth of controlled, experimental confirmation that would let researchers state, with full confidence, exactly how that cognitive capability compares category by category to better studied species. Some researchers argue the coyote's demonstrated behavioral flexibility places it among the more cognitively capable mid-sized mammals on the continent, while others urge caution against over-attributing sophisticated reasoning to behavior that might, in some cases, be explained by simpler associative learning, operating at scale across a genuinely enormous and widespread population. It remains a live, active debate within the field. One final reminder that even the trait most thoroughly documented throughout this entire story, the coyote's remarkable capacity to learn and adapt, still has real boundaries that science has not yet finished mapping. Look forward rather than backward, and one further open question comes into focus, because the urban adaptation already documented so extensively throughout this story is very likely nowhere near finished. American cities continue expanding, converting former farmland and open space into new suburban development at a steady pace. And researchers studying urban coyote populations are watching closely to understand exactly how much further this animal's demonstrated capacity for behavioral adjustment, the nocturnal shift, the traffic navigation, the use of storm, drains, and rail corridors as private travel routes, all already described earlier in this story, can actually extend as cities themselves keep changing shape around it. Some researchers studying this trajectory suggest coyotes may be approaching something close to a genuine behavioral and ecological equilibrium within urban environments, having already made most of the major adjustments this kind of habitat requires. Others argue the species' demonstrated track record throughout this entire story, adapting repeatedly to challenges that would have seemed insurmountable to wildlife observers a century ago, suggests real caution is warranted before assuming any current limit represents a genuine ceiling on what comes next. It is a question with no confident answer available yet, precisely because the underlying situation, American urban development and coyote adaptation both continuing to unfold in real time, has not yet reached any kind of settled endpoint. Researchers can study retrospectively. The coyote's urban story, in other words, is still actively being written by the animal itself in real time. Gather now everything this story has laid out across every stage, because the full shape of what the coyote has actually accomplished only becomes clear when it is held together in a single view. This is a species that endured over a century of sustained, well-funded, and often genuinely brutal eradication effort, poison distributed across entire regions, aerial gunning still conducted today. Millions of individual animals killed through bounty and trapping programs that in scale and duration rival or exceed the campaigns waged against nearly any other predator in North American history, wolves and grizzlies included. And through all of it, rather than retreating toward the fate those larger, similarly persecuted predators actually suffered, the coyote expanded, spreading from a regional western range into a genuinely continental presence, colonizing environments as different from each other as desert scrubland and downtown Chicago, doing so not through any single dramatic breakthrough, but through the accumulated weight of everything already documented. Throughout this story, compensatory reproduction, dietary flexibility, rapid and lasting learning, and a physical body built for exactly the kind of sustained, ground-covering resilience this entire effort demanded of it. There is no other predator on this continent with quite this same story, hunted this hard for this long, and simply refusing the outcome that hunting was designed to produce. Whatever else gets said about the coyote going forward, that basic fact deserves to stand on its own, plainly stated without embellishment, because the reality of it is already remarkable enough. There is a deeper irony sitting underneath that entire accomplishment, one worth naming directly before this story reaches its close. Each individual method deployed against the coyote across this long history, the poison bait, the traps, the aerial hunts, the bounty programs, did not simply fail in isolation. In a very real sense, documented repeatedly throughout this story, Each one appears to have actively contributed to the animal's growing capability to withstand the next threat that followed it. Bait-shy animals, passing that caution forward into populations less vulnerable to future poisoning. Efforts trap avoidance behavior, generalizing across new trap designs. Compensatory reproduction, converting population pressure itself into fuel for recovery rather than decline. The very campaign designed to eliminate this species may have functioned across generations as an unintentional selective pressure, favoring exactly the traits, caution, adaptability, reproductive flexibility that made the coyote as difficult to eliminate as it has proven to be. This is not a claim that the eradication effort was somehow secretly beneficial or that its architects intended any such outcome, a suggestion this story has no interest in making. It is simply an honest observation about how a century of sustained pressure interacted with a genuinely adaptable species, each failed attempt at removal, potentially sharpening rather than diminishing exactly the qualities that would be needed to survive whatever attempt came next. And so this story arrives, finally, at the question worth carrying forward long after it ends. Everything documented across every stage of this narrative, the coordinated deer hunts and the studied fence lines, the bow jest chorus and the independently swiveling ears, the wolf DNA, quietly written into an eastern coyote's frame, the golf course mower schedule learned and respected, the 100-mile journey undertaken alone by an animal not yet a year old, the century of poison and bounty and aerial gunning that never once produced the population collapse. It was designed to achieve all of it points toward a single, the harder question sitting underneath the more obvious one this story opened with. It would be easy enough to ask simply how the coyote has managed to survive us. And this story has answered that question as fully and honestly as the available evidence allows. But there is a second question tucked inside the first, less comfortable and considerably larger in scope. One, this story can only leave open rather than answer because no one researcher or rancher or backyard homeowner alike has yet arrived at anything resembling a settled response. If the most sustained predator eradication campaign in American history could not remove a single mid-sized canid from this continent and may have made that animal more capable rather than less, what does that actually reveal about the real limits of human control over the wild world? We share limits we have perhaps never fully reckoned with and may be reckoning with still. Every time a coyote crosses a city street at 3 in the morning and simply keeps walking. Thank you for spending this time here with me. Until next time, good night.